All right, here we go. Okay. Is it a hump or a drop? What do you say? You got to twist your words in every which way, because the motto will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line or does it curve? Some people unclamp it, but that is absurd. We all know that the model will always dictate what you do. Everybody knows that you are model afflicted blue. Model affliction, it's your addiction. That model affliction, it brings you so much pain. It's your ball and chain. Conflating curvature with elevation change has got your local distance just out of range. That old biggie is gonna dictate everything that you do. And everybody knows that you got the model affliction blue. It's your decision defending the model position. You just don't know the geometric proposition. That old ball, it'll always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction, it's your addiction. Model affliction, it brings you so much pain. It's your ball and chain.
World famous Buster.
Today.
And we are live. Welcome everybody. It is Model Affliction Monday. And welcome. It's Monday. Yeah. Welcome, Rob. Rob said his model. Is it Model T Ford? Left the shop.
No, it's a Model A. Model A.
A.
It's a 1930 Model A. Left the bay today.
I don't know. I think everybody got a chance to see it on Friday, was it?
Yeah. No, I posted a new video today of it leaving. So if we want to post a picture of the model leaving, that would be funny.
Hey, at least you had that privilege, Rob. That's pretty cool.
Yeah.
Thanks, guys.
Yeah, the model leaving, getting rid of it. Get rid of the old model. and bring in a new one, the real one. Because I've got quite a few bits to go over today. Strangely enough, like, we're on about wrapping this up and letting everybody know what we've actually been doing here. I think, me personally, I've been developing, I don't know, a sort of philosophy, I guess you could go. I've been studying metaphysics and interaction between different people, basically learning myself how to have conversations. And the journey that I've been on has been absolutely marvelous, through Trivium and talking to everybody. But just recently, there's a few arguments that have been around right since the beginning, and this is sort of shows you what happens within, let's say, this arena, where you come in with the intentions of just asking questions, you know, trying to meet people and develop some, I don't know, understanding about things, and end up with finding out really that, like, people say that everything's a lie, but I wouldn't say that. I'd say there are truths out there, but you find out how little you actually know about actual reality, and most of it has been given to you shadows on the wall, not knowing what reality actually is. So coming into it, I had questions or rather people had questions of me, and in that they dramatically labelled me wrong, and which has led me to be here where we are right now, in this tiny little corner of the internet, with some, I consider, marvellous mathematical proofs of reality, proper links to reality. Go all the way from logic, first principles of logic, all the way through the first principles of geometry, and to the first principles of mathematics. We can go right through the lot of it. There's proofs all the way through, from the beginning to the end. People have labelled us flat earthers wrongly. And that's only because they've got a model. They've got a model that they can't get rid of. And it's strange that the people that have we're going to lead this conversation tonight, where they've come from. You know,
even the flat earther doesn't think it's flat, though.
Well, that's the argument that they say. So they say, by saying that you don't think it's flat, then you are a flat earther, right? Like, you're a flat earther, and you say, well, no, I have got a proof it's not flat. And then they say, oh, well, you're a flat earther then. There's no way of getting away from this. And then when you say, oh, no, it's not flat, then the flat earthers don't want to know you as well. And they start having a go at you for saying that it's not flat, because they want everybody to say it's flat. They say, well, when we know it's not flat, but we call it flat. It's just absolutely ridiculous. The whole fucking arena is as stupid as you could get. And all of this ridiculous arguments, non-arguments, they're not even arguments, all of that happens because people don't want to actually have the argument. Nobody wants to go, well, what's your proof then? Nobody wants to work through the proof from the first principles. Not one person in the 4 years that we've been around here of us saying, look, it's open for anybody to come in. Not one person's come in and has said, what is this proof? And that's because nobody wants to actually know. And that's where we're getting to now, like tonight, this ridiculous argument that people came to me with from exactly the minute I joined this arena. So, you guys, I'm going to put it on agents. I'm going to go way back because this is going to take a while. So, well, I don't know how long it's going to take us to get here. Oh, there's Rob and his car running. That was from Friday. Right, so I put a tweet out. It was the national debate champions. I don't know if anybody's seen that for this year. And thinking, you know, like what have they done to modern day debate, right? It's changed completely. It's not even a discussion anymore. That nobody can understand what's going on. Nobody in any of these chat rooms, nobody can understand what anybody's talking about. Nobody calms it down enough to actually get a message across or get a conversation going. So I put that out. I said, and I thought we were struggling because of the topic. It seems like modern day debate has taken a turn for the worst. Let's bring back simple, informed conversation. That's what I put. And then there's a guy called Kenny. Says, I think this is Kenny from the Blue Marble Science guys. He says, is that what you call it when you use your fabricated reality as a basis to ridicule anyone that points out the flaws in your arguments? So that's Kenny. Pretty brave. Let me move this over. There's going to be a few of these and then we're going to go over to a video. What I'm doing over these last few weeks before April starts is trying to document my journey into this place, just so everyone can know where I actually came from before we actually start what we came here to do. It's all changing. Everybody knows it's all changing. You can feel it changing, can't you? Changing in the air. And then this character called KC, and KC's from Twitter, from the very beginnings of this particular conversation when I was talking about setting up this realizing Euclid test because somebody had said, can you prove that level is horizontal? They actually set me that challenge, and I said, yeah, I'll give it a go. So we came up with yeah, thank you very much, Constance. So yeah, I was just setting up a test because somebody said, can you do it? Prove me. It was some fat guy, fat fighter or something. And he was he challenged me. And I said, yeah, okay, I'll take that on. Met a group of people. Here we are. So she says, well, Bev, Euclidean axioms don't apply to a non-Euclidean space. Non-Euclidean space has its own set of axioms. Because we do geometry, right? I don't know if anybody knows that. First thing we ever did was go back to first principles of geometry. Because somebody said non-Euclidean. And this is one of those people that uses this non-Euclidean. So it depends what you imagine non-Euclidean is. If you have a firm foundations and a fundamental understanding of Euclidean geometry, then a non-Euclidean is a bit hard to conceptualize, really. But I mean, obviously, that's where we deal. We deal in the Euclidean reality, and these guys are fantasists. So talking about non-Euclidean has its own set of axioms, as if that is possible.
Which ones?
Yeah, we'll get to that in a bit. Right? Look at that. You made me sully this account with flat earth nonsense. I see nothing has changed in the last 3 years. 3 years from Twitter, from the initial onset of me conceptualizing this, and then 3 years since I've left Twitter, really, to come here and start talking about people. Met Emma and Spot On, Turn Up, and, you know, everybody, all of that, Buster. So I say, why do you think non-Euclidean geometry is flat Earth geometry? And where exactly do you imagine non-Euclidean space is? I only deal in reality. You should know your flat Earth society games won't work. See, because I'm not flat earther, right? But I consider the people that mention flat Earth, every one of them, flat Earth society members. There's literally no need to bring it into any conversation unless you are the ones that want to inject flat Earth, which is fucking ridiculous. It's obviously not flat. Let's talk about reality. So that's where we're at. So this again, it's going to be a lot of this from Casey now, because obviously the Casey agent button has been triggered again. Casey, if you're listening, Casey, shout out to your friends. Anybody want to put this out? Because this is the dogmatic model right now. The dogmatic globe model. This is what they have to believe. And this is where it was first conceptualized by people on Twitter. None of this stuff that I've been talking about here has ever been done any more so than these from Twitter over 3 years ago. This is Flat Earth Society. This is where the arguments, the non-arguments, were laid down by this group of people. And it's had to follow through into it. So, Casey says, concepts, this is where we get into the, I don't know, meta physics, meta geometry. I guess it's metaphysics, all right, because we're dealing with reality here. And the way we, well, I'm talking about actual test in reality, right? Now, you judge for yourselves where the meta part of all of this comes in, and who has a model and who's being afflicted by their model. So Casey says, concepts also exist, Bev. Thoughts exist. A semantics argument isn't going to get you anywhere. Now, I would say things exist. I wouldn't say thoughts exist. Personally.
I would say they exist, but not in Euclidean space.
Yeah, so, it's again, like she's saying, semantics argument isn't going to get you anywhere. So again, we're into a semantics argument about the existence of thoughts rather than actually taking it going anywhere, right? I think that's what the play is.
Yes, this is Strawman, because Euclidean geometry is 3D geometry. It means physical reality, and thoughts don't belong to that reality. So she is confusing, let's say, intellectual reality and physical reality. So this is Strawman, just Strawman.
Well, this follows on for 1 minute after it. A tweet goes, you really have no clue what you're talking about, do you? The surface of a sphere is non-Euclidean. That doesn't mean that Euclidean space doesn't exist off the surface of the sphere. Capitals out, the off. So concepts exist, like the concept of non-Euclidean surface of a sphere.
Maybe this concept exists, but this concept is illogical. So, okay, this is fantasy, yes. Nothing more. You cannot prove anything with fantasy.
Well, again, I'll have to point this out. The surface of a sphere a three-dimensional solid geometrically defined figure, a sphere, is non-Euclidean. Strangely enough, the sphere is defined within Euclid, Book 11, solid geometry. So the surface of it is not Euclidean.
This is false statement. So nothing more to say. Just false statement of fact.
But you'll see what has happened. Hopefully, if we can get round to it later on through all of this, because I think it's almost like the water level changing the definitions. And then this one here, Casey says, we can absolutely use Euclidean geometry to prove we live on a globe, Bev. We've been through this before, which is, she shows a parallel postulate for Euclid, and then a stolen concept drawing that she made for, or no, sorry, the guy that may or may not, or probably doesn't live in Maine. We're going to talk about it later. She was one of his biggest supporters, and so she did all of this graphics for him on Twitter. Back in the days when he was still around bullshitting about being a surveyor. So, we'll get round to, I've got that video to come up in a bit. She mentions it. I don't think non-Euclidean geometry is flat earth geometry. What the fuck are you talking about? You try to use your understanding of Euclidean geometry to disprove the globe. The surface of a globe is non-Euclidean. Surface of a globe is non-Euclidean. So you have to show that non-Euclidean geometry doesn't match reality. There you go. Claim. The surface of a globe is non-Euclidean. Just a blatant statement. To which Casey follows it up with, you have to show that non-Euclidean geometry doesn't match reality. That's up to you to do.
The double negation, and to prove that this is not Euclidean. This is typical trick. This is baby-like.
Well, this, I won't just
Maybe
point...
it was baby. I don't know. But
this character is a mathematics teacher in Canada.
Okay.
Okay.
But,
different spin on it now, right?
But still, kind of argumentation is basically the same. I would say identical to Baby's type of sophistry, because this is sophistry, pure sophistry here.
Yep. Oh, yeah. There's quite a few of these. I did a thing about north, south, and east and west lines, which I think we'll go over at Euclid times. This guy says, I say north, south, and east and west. How many of those lines are circles? To which Chris says, none, but they form semicircles, which, if combined, does create a circle. This is just sort of the fantasy stuff that I have to deal with in my daily life. I bet you can't even work out what that answer means, do you? But I'll go back to that one at some point. And this is a farmer's boy called Roger. Says he treats Emma's server as his own. Oh, no, sorry. I'll read them the other way around. These ones are. So, Robert Baker, or at Dr. Bob. I don't know who that could possibly be. I don't know of any doctors called Bob anymore. I think they had to lose. All of the doctors that I know that were called Bob can't be called doctors anymore. So I'm not too sure who this one is. Maybe it may be a PhD doctor or something called Robert. I don't know. So this Robert Baker at Dr. Bob double B58 says, on the level is Bunny Ears your server, regardless of whose name Discord has on record. Like, so it doesn't matter who actually owns the server. He's going to say it's yours. It's all about you there. Not so really. These shows are where I do my live shows from. So this is definitely about me because I'm doing a show from this Discord server here. He says, I'm not overly sensitive. I'm simply not a masochist. Name calling and ad homs is not pointing out contradictions. Don't be such a muppet. I don't know if anybody's listening to us or whatever, but I haven't got a clue. Name calling and ad homs. No, cat. And then Farmer's Boy decides to jump in and says he treats Emma's server as his own. He likes to maintain deniability, not his server, not his photos, not his level. He just acts like it's all his. Okay, so for any farmers boys out there that are listening, this is not my server. It is my son's Discord server, not Emma's Discord server. The photos that my son takes are my son's photos. They're not mine. So, Farmer's Boy, whether you imagine that they are my photos, they're not. If you imagine this is my server, it's not. Pretty simple. But, hey, this is the way the misinformation gets spread. This is how paralogisms get handed out by people, I guess, say people that just lie about stuff. If anybody wants to come and have a conversation about it, you're quite welcome to. Just come on in, have a chat. It's an open server for a few weeks. Okay. This one says, Casey again, the surface, big capital letters, of a sphere is two-dimensional. It has an area, capital letters, which is 2D measurement. We aren't talking about the volume of a sphere, Bev, only measurements on its surface. The radius of a sphere is perpendicular the tangent of the surface at every point on the sphere. Horizontal and vertical change with position on the surface of a sphere. In reality, we can measure how much vertical lines deviate from each other across the surface of the Earth, says Casey.
Okay, so how do they do that?
It's a fantastic claim, isn't it? Yeah.
We are waiting for
claim.
years. They always say we can, but they can, but they cannot show. This is strange for me. If they can, why they cannot show it? They never showed anything. So please show us. How did you do that?
I did most of this yesterday, so, and then we'll get back to it, right? Yeah, I did ask, and we'll get back to it, and that's where we'll go to the video next. So Kenny, who has been round here, I think he's been round here. He's been in the chat. Most people will know him as a Kenny from the Blue Marble Science Discord server, and sometimes Kenny comes in the chat, text chat trolls. So you guys out there in the chat will probably know Kenny. So Kenny says, like out of nowhere, just a random question that you hand out to people. I don't know if anybody else gets people asking you questions like this all the time. what is the shape of the Earth based on sea level elevation, ignoring all topography? I don't answer questions like this because it's just fucking ridiculous. And then a farmer's boy again decides to come in and says, no, topography is his entire argument. I don't know what he's done. We don't ever mention that. So it's not even been part of an argument.
Wait. I can answer that. Earth without topography has no shape. So this is my answer.
Yeah, you take all the shape off it.
Yeah, so no shape. There is no shape for the Earth without topography. So,
well, Kenny, right? This is, if you're asked, what is the shape of the Earth based on sea level elevation, ignoring all topography, right? And then, after a bit of encouragement from a farmer's boy, he says, anyone that can't immediately answer spherical is a flat earther. That's anyone that can't. If you can't immediately answer, if you go like, what the fuck's that question mean? What are you talking about? Why are you asking me ridiculous questions? Kenny be calling you a flat earther. So that's how hard it is to get away from people, this particular group of people wanting to call you flat earthers. Now, I think this group of people are Flat Earth Society members, and they are recruiting for the Flat Earth. They know it's fucking ridiculous. They know how bad it is, but they need people to join it. I'm not a flat earther, so I don't give a shit about it. I do like the argument, though. I like the argument, and I like finding proofs in reality. So that's what all I've ever been after. So, and again, here we go, contradiction, right? Anyone that can't immediately answer spherical is a flat earther, says Kenny. He says, calling the ellipsoidal shape of our planet a horizontal plane is being a flat earther. Is ellipsoidal spherical? Shouldn't you immediately answer ellipsoidal? But I don't know. I guess he's going to allow you some sort of a...
nobody is saying that Earth is horizontal plane.
I know that, yes. But this is Kenny. He's been round here. He's one of the best of the... I don't know. Blue Marble scientists. He's recruiting for the Flat Earth. Recruiting for the Flat Earth by saying, if you don't immediately answer something, he can just put you in the Flat Earth.
By the way, he can put us wherever he wants. So, okay, no problem.
Okay, so that's Kenny. Now, Kenny won't be able to entertain an argument, and Kenny won't be able to see the proof that we have that the Earth is not flat. And that isn't just looking at a picture of a mountain. We do actually have a proof that the Earth is not flat. Proper mathematical proof that involves mathematical thought to go into it. So if anybody wants to come and go over it, you can. We've got a website there. You can go over it. You'll probably be able to see many of the tests on there somewhere. I'm trying to make it a bit more user-friendly for you to be able to get around the website. So I asked KC about this. About, you know, really, who's measured it? And so KC says, you've already chatted with a surveyor that could, Bev. The guy that obviously isn't a surveyor. We don't even know whether he lives in Maine or not. He's gone away, he's run. He says, you're being dishonest. He made you a video and everything. He made me a video. Do you want to go and have a look at it? It says here on this video, with a little help from KC. So KC's got in there. So let me just get this set up. Oh, where did I put it? There we go. You guys in.
The main surveyor modus tollens. We can see.
Okay. Yeah, let me just move this over. Right, there you go. On Discord. You guys in Discord are good. Everybody can see this. So this is it says there's a YouTube channel from a guy called The Main Surveyor. It's just a character. There's no need for you to take anybody that seriously when they're just because they're on YouTube, right? And he's made this video with the aid of a mathematics teacher from Canada, purportedly. I think that's what the character of this other one says. So here we go. Main Surveyor. He's got 510 subscribers, so get over there and give him a follow.
Well, good morning from the state of Maine. I thought today we should talk about some of the underlying principles, again, about plumb lines. And KC, who's a geometry teacher, she put together...
See, he calls her a geometry teacher. So that's how you know it's definitely real, right? When a character that's playing a surveyor, obviously he's not a surveyor, where he's giving credibility to another person as a geometry teacher.
I would name her a sophistry teacher because she's just exactly the same. So if her posts would be named Baby or Edby, I wouldn't be surprised. I am not saying that she is he, that she is Baby, but she's just using completely the same kind of sophistical argumentation.
Yeah, this is initially what got me started on this, because this is where I came into it with the geometry, going to learn the first principles of geometry. Now, I've tried to pass that on to everyone, and I think most people are up to date with it now, but this is me going back now. Well, not going back. This is somebody from 3 years ago that's coming, and the arguments haven't changed, right? So now you people can get a chance to see, and hopefully you've got a little bit more of a underlying idea of the geometric principles at the beginning. Now we're going to go through this, which obviously we went through. I went, how long's this? 2 years ago. I mean, this video was made 2 years ago. And he's given her credibility by calling her a geometry teacher. So this will be obviously come from a geometry teacher.
Some of the principles here spelled out that are depicted in this graphic. So the modus tollens, if plumb lines are parallel P, then the sum of the interior angles, which in this case is zenith angles, will be 180 degrees.
The sum of the interior angles will be 180. What's that mean? As a logical statement, if plumb lines are parallel, P, premise, you can have any premise you want. But like Emma says, mind your P's and Q's. So that's your P statement. Then the sum of the interior angles, brackets, zenith angles, will be 180. What does that mean?
That they would be parallel.
The sum of the perpendiculars? Or just the sum of the zenith angles? Right? What's a zenith angle? And a zenith angle what? To another plumb line? What's exactly, how are you forming a logical statement? What does it mean? And the Q statement is absolutely messed up within that. Then the sum of the interior angles, brackets, zenith angles. They are plumb lines. What's a zenith angle as pertaining to plumb lines? What's that mean?
Plumb lines, they are always vertical. So
yeah. So what is the sum of the interior angles? Zenith. What doesn't mean anything, does it? It's a vacuous statement. But okay, right? We've failed at Q, but let's carry on.
There is no interior angle here.
No. Not within the logical statement anyway, within the argument, right? Within the modus tollens. The modus tollens does not need a picture to come with it. If you're looking at the picture whilst you're reading this, you're being influenced by images. You're making up the argument for yourself. It's a very clever magic trick to do this. I have been over this quite a few times, and I think this is one of the best examples of how you can completely fuck up with your P's and Q's. Don't take Emma's advice. It's one of the t-shirts that's definitely going up this. Emma says, mind your P's and Q's. All right, here we go. Let me go on.
Q. The sum of the interior angles, zenith angles, is greater than 180 degrees.
Just a claim. Like, that thing that you didn't even know what he was talking about with his Q. He's just going to claim they are. They are that. Is it, like, do you like it? This is Globjic. This is how they do modus tollens. This is how a missologist does logic. Somebody hands it to them and they just read it out. Sorry, go on, Paper.
No, I just said that they are because they are.
Mm-hmm.
This is what he's saying.
Yep. Well, no. I think this is what KC made for him. Put his graphic in it. Sent it to him. And now he's putting this at the beginning of a video. Something as, you know, like the scripted narrative has led this guy to make this video using a meme that KC made, right? Obviously he's a missologist. He hasn't got a clue about logic. This was 2 or 3 years ago when logic was all the rage. Everybody had a black swan and a modus tollens, but nobody understood what the modus tollens was, and nobody listened to Emma stating, mind your P's and Q's, will ya, people? This is vitally important within your logical argument to get your P's and your Q's sorted out. Make sure your Q's follow your P's. And make sure that they are actually... so anyway, you just... Yeah, that's how you do logic and modus tollens with this. You just state that they are that. They are more. So therefore...
Not Q. Yep. Therefore, the plumb lines are not parallel, not P. So
your plumb lines are not parallel then. That easy to do. Bish, bash, bosh. Modus tollens. That's how you control logic. But he's not finished. He's not finished.
As drafted, we can tell that these two plumb lines are not parallel. Because
as drafted, this is the one, I don't know whether you can see there. It's got 94 degrees on that side and 94 degrees on that side, which added together makes 108. Sorry, 98. Sorry, 188. Which is 8 degrees over. And everybody knows that the so-called, what he's trying to do here isn't, it's just an angle to a light in the sky. But 1 degree to every 69 miles, 8 times 69 is just like way too much. It's an impossible, it's a world record breaking vision sighted thing. And he's done it with theodolites. It's fantastic, some sort of achievements that these characters that pretend that they're surveyors do.
Extraordinary theodolite.
Mm-hmm. And because somebody's give him some modus tollens logic that he hasn't got a clue about, and nobody's bothered checking it or anything, they could have come around here and asked us. We'd have sorted that out for him. No problem. But hey, we've got a proof now, right, that plumb lines aren't parallel. A logical proof. Logical proof.
Angle A and angle B add up to greater than 180 degrees. And then she added the parallel postulate, which is...
In his picture. Look, in his picture, look, he did it to show that the angles do add up to more than... Just drew it. This is the guy that everybody knows. Everybody cites this guy. You've probably seen a video for him, or somebody's posted a video for this guy in the chat room at the side. Probably may have been B-Ball or one of the other people. But here we go. This is absolutely fantastic that they've added this. Here we go. Listen.
Parallel. Because angle A and angle B add up to greater than 180 degrees. And then she added the parallel postulate, which is Euclid's fifth postulate. If a line segment intersects two straight lines, forming two interior angles on the same side that sum to less than two right angles, then the two lines, if extended indefinitely, meet on that side which the angles sum to less than two right angles. So these angles down here must be less than 90, each of them, is what this is saying. They're not dimensioned here, but we can see that they are heading to a point where they're going to intersect. So let's pull up the AutoCAD drawing that I created that from, right?
What do you reckon to that?
He got better drawing that will prove better.
Yeah, but what's he going to use? He's going to use this is where I said stolen concept. Don't tell him. Don't tell him. That's where he's going. See whether anybody else notices it.
Okay, so this may be difficult on a mobile device for you to see, but it's the same graphic, and what I've added down here at the bottom are the dimensions. So all I did was click angular dimension, click the line of sight, click the plumb line.
You can see there it's 94.
And it sticks it like that.
ATR.
Pretty neat.
Mm-hmm.
So both of these angles underneath the line of sight are less than 90 degrees.
Quite a lot less, because as you can see, just these ones, these ones were absolutely impossible to be able to be sighted. These ones are equally, well, as you'll see, this line here has 180 degrees on it. So the addition of this one here and this one here makes 180 degrees, strangely enough. He's talking about the parallel postulate. And he's using the parallel postulate to prove, what's he using it to prove again?
So we look at the parallel postulate again.
But they are not parallel.
If extended indefinitely They'll meet on the side, which the angles sum to less than 2 right angles.
He's making it, confirming it there. He's just reading
check that out.
Look. We're gonna
let us draw a line down here.
Mm-hmm. This is good at AutoCAD, isn't he? Look at this.
Those 2 lines.
I can't do this. I never had this ability to do all of this sort of stuff. But these guys did.
Oh, look. They meet right there. There they intersect. And we can trim.
Look, they meet.
Those 2 meet.
They meet.
On the side where the angles are less than 90 degrees.
And there you go. There's your proof.
So this graphic
on AutoCAD, yes,
plumb lines that diverge as they increase with elevation, we see that they must converge under the ground. That's kind of neat. So there's more graphics that go.
Isn't it kind of neat, that stolen concept? It's kind of neat. For anybody that doesn't understand what a stolen concept is, it's where you take the initial proposal and then use that to prove that the initial proposal is false. So what we've got here is vertical and horizontal being perpendicular, as in having a relationship of 90 degrees to each other. Now, all perpendiculars to a plane will be parallel. So, quite cleverly, what you've got here is a guy that claims to be a surveyor that's using basic concepts of geometric reasoning to prove that perpendiculars aren't parallel. But even better than that, the thing he's using to prove it is the 5th postulate. Or what we call the triangle axiom. He's actually using the triangle axiom to prove the perpendiculars. Actually, what he's trying to do is he's disproving Euclidean geometry using the triangle axiom to prove that the triangle axiom doesn't actually exist in the geometry that he wants to move over to. But I don't think he realises that yet. He's using the very thing that he's not allowed to use within his proof that the stolen concept may seem a little bit tricky for you to get your head around because it's fantastic. Such a great story. Like this sting when somebody just sort of opens up to them, everybody, and says, here's the game. This is exactly what we're doing. I'm going to show you how messed up my logical system is by using the very thing that I'm going to say doesn't exist later on in a different geometry. In fact, I think Casey's already said that, hasn't she? Casey said that the surface of the globe is non-Euclidean. So that's what he might be proving here using the triangle axiom. The actual surface that he's on isn't Euclidean. He might be using Euclidean geometric principles and foundations to prove that it doesn't actually exist. Fantastic. What do you reckon? Is everyone following along? Does everybody understand why I'm still here trying to work out what's going on? Or is everybody else's heads messed up right now? Yeah, okay.
Not mine, I think.
Do you understand what I'm getting at?
You already did.
Yeah.
For me.
So yeah, you do understand them, right? It's not just that I'm talking shit that nobody else understands. There is at least one person that understands what I'm saying. Is what I'm hoping for.
I understand what you're saying, Beth.
Thank you.
With this whole set.
Sorry, my phone was on the other side of the shop.
Yeah, no problem.
Look at those. So it was just describing, so this is what an occupy station looks like. This is a symbol that we use. And so we have a plumb line
symbol.
And therefore a 90-degree zenith angle is horizontal to the plumb line, right? So that's implying that there's a 90-degree angle there. And we dimensioned it and we see, yeah, that's 90 degrees. Now, here's a case where
look,
the ground is flat. And we have occupy station A and B. They have the same horizontal line. They have plumb lines that must be parallel. So we don't have to dimension here because this has to be 90. But we can skip back over to this AutoCAD drawing. And
look, he's drawing another drawing.
Angles.
Does that prove?
And there it is. 90 degrees. 0 minute, 0.
That proves this one. This drawing here. Obviously, because that's why we're doing it. Anything he draws is proof. This is proof that the plumb line and the perpendicular to the horizontal is always 90 degrees. The relationship. This is the perpendicular of vertical and horizontal and the relationship of perpendicularity right here in this drawing.
Seconds. Very nice. Let's do the other side. And that's all 90 degrees as well.
Just geometry, right? Just geometry.
So all that's 90 because those plumb lines are parallel. Fantastic. Okay, so we get that. Now, even if one of them's elevated on a hill, the underlying surface of the earth there is flat. So these plumb lines...
It's got nothing to do about the surface of the earth, this. Don't be fooled by a magician. The surface of the earth has nothing to do with these tools that he's using. Nothing at all.
Lines, these add up to exactly 180 degrees. And they must on the bottom as well.
That's because there are 180 degrees or two right angles within a straight line, and there are 180 degrees, i.e. two right angles within a triangle. There are also two right angles, 180 degrees, within a semicircle. And the relationship of these, the straight line, the triangle, and the semicircle, is abundantly clear once you understand the fundamental basics of Euclidean geometry, which I encourage everybody to come in and see the proof that we have. It takes all of these first principles into account. You will listen to the proof from first principles all the way through. Don't get hasty with us. Yeah, you're not allowed, Wally.
Now, if the earth were concave, the horizontals here.
Look, this is where he starts getting a little bit stupid, right? This is where you know this is flat earth society. He's pretending to be a surveyor and he's saying if the earth were concave, and then he slopes horizontals. Horizontals don't slope. There's no such thing. Why would anybody ever be doing this? Like, it just doesn't happen in reality. So why draw it as though it's like nonchalantly just sort of, here, look, this is what happens if the earth is concave. It's not. It never happens and it never will. But something's happened in this guy's head that maybe it's just for YouTube clicks. Maybe it's his scripted thing. Flat Earth Society is what I call it.
Are not parallel.
It's not a surveyor.
The plumb lines are not parallel. We have a line of sight between the two occupy stations, and angle A and angle B add up to less than 180 degrees. Therefore, these plumb lines can't be parallel.
Look at the angle he's put in it. 68 degrees. He's not even keeping it within the realms of reality. I think he's forgot about the 1 degree for 69 miles, completely. I think he's expecting that all of the people that are going to be watching it have forgotten about it too. This is just ridiculous.
Now, with Euclid's fifth postulate, these two lines must converge on the side where the angles are less than 90.
What? With Euclid's fifth postulate, the lines must converge. What's he talking about? This guy's meant to be a surveyor. And he's meant to have got advice from a geometry teacher. Now, admittedly, none of us are geometry teachers, but we do have a good understanding of the first principles. This isn't it. And this isn't how you explain the triangle axiom to people.
Not that I want to get into this, and I've only been half paying attention because I'm working, but I don't quite understand why these things are labeled the way they are, because no surveyor would ever label that thing that looks like a curved line the ground, especially in that kind of configuration where it's convex. And they would also never label something that could be so far apart, seemingly, if these are supposedly the model, quote unquote, model numbers or diagrams. Could you ever get that far apart and have some kind of line of sight that's valuable in any way, shape, or form? I don't think so.
No.
So
no,
this
but
is
you would never draw horizontal sloping. I mean,
no.
You just look at it. It looks fucking ridiculous.
It is ridiculous.
Yeah.
So this is some kind of proof? This is some kind of proof of what? Fantasy drawing? It's certainly not proof of our reality in any way, shape, or form.
No. Like I say, this is the early stuff that I came into this stuff with. This is what set me on the path to find the first principles. As I'm discovering them, I mean, they put this out to me, and I'm thinking, you can't use Euclid's fifth, as they call it, which it isn't. It's the 12th axiom, the triangle axiom. It doesn't even mention parallels within it. So, what they're talking about is forming a triangle. And they're on about forming a triangle between perpendiculars, vertical, horizontal. That's what he's talking about.
This is madness.
Literally, he's talking about forming a triangle using perpendiculars. He's falsifying the perpendicularity between vertical and horizontal. He'll say he isn't, and nobody else will go with that, but literally, that's what this idiot's doing. And he's using the triangle axiom to do it. Like a fucking dickhead.
Yes, he is doing that, but still, maybe he thinks that this is proof of something, while it is not.
He thinks it's a contradictory proof. It's a proof that...
No, it is not proof. The parallel lines and perpendicular have nothing to do with triangle in that sense. So he's just joining two separate things as one. I don't know why, but maybe he thinks that this is a proof, or maybe he thinks by advice of this lady geometer that would sound very smart and sophisticated for average, let's say, listener. Maybe that's why he's doing that. because normally nobody would understand, I think, because this is nonsense. And the second, that this is sophisticated, let's say, language. So maybe average listener would not pay attention. He is talking about Euclid, postulates, perpendicular triangles, etc. So he is very smart. And people who don't understand what he's talking about would say that this guy is okay. He's very, very intelligent. So he has to be right.
Can you see in the live chat?
Pardon?
Can you see in the live chat?
Second.
Because there was another guy that came round here with something that looked very similar, and I handed him the 12th axiom.
But Bev, those two plumb lines he has identified are not hanging vertical in that last drawing you showed. How could you identify those as plumb lines when they're at an angle? Now, see, this is where the what is it? The gravity thing comes in as a synonym for vertical. No,
we're just dealing with vertical and horizontal here.
Yeah.
But
how can you claim a plumb line to be not vertical?
Well, that's the thing. Like I say, I handed a guy called Wally. Everybody's leaving. It's tough. I handed a guy called Wally a similar thing because he said, he showed me a similar picture, and I said, "Oh, that looks like." I'll hand him this, and yeah, he's done exactly the same thing. Go on. Yeah, he's done exactly the same thing. He's posted the triangle axiom there and used it as a proof for his things meeting. So he's using perpendiculars and then adding
no,
I would say that axiom to prove
I would say that
falsehood.
That he's just mentioning triangle axiom, and it is proof for parallel lines being not parallel. So this is not a proof. Just mentioning triangle axiom proves that parallel lines are not parallel. Therefore, we have triangle. This is nonsense, of course, but this is what he's saying.
No, it's not just
video.
him, right? This guy, he did it 2 years ago. Wally's here. He's telling everybody that he's done the same thing. Wally's taken this to Nathan Oakley. Nathan Oakley just dismissed it. Obviously didn't go over the fact or see it for what it was. It's their proof that plumb lines aren't parallel. Now, the relationship of a plumb line to a horizontal is that it's perpendicular. If they're not parallel, that means that they can't be perpendicular. Literally, it's a proof to show that vertical and horizontal are not perpendicular. Break it down. There's no other way to do it. This is a stolen concept fallacy where he's using the very postulate that he's not allowed to use. Because when they do their switch to non-Euclidean geometry, they say there are no parallel lines. That particular axiom has to go. So how can you use it to get rid of it? That's what they're doing.
Yes, and he is using, and they are using circular reasoning, because in their outcome, verticals are diverging. So, and they say it many times, that if verticals are divergent, therefore we have triangle and not parallel and perpendicular lines. But this is circular reasoning. If you have to check or examine or test, make experiment that they are not parallel to each other, that they diverge first. And then you can say that they are not, that verticals are diverging. It has to be tested. But if they are saying that if these lines are divergent, therefore, and they are trying to make some argument. But you cannot do that because your outcome is already given. So they are giving outcome and they say that this is their premise. You cannot do that in logic. This is circular reasoning. You cannot have a conclusion as a premise. And they cannot see that they are just making circular reasoning here and there, everywhere.
Yeah, I would take it, right? If plumb lines aren't parallel, then when you have a horizontal between the two of them, which has to be a straight line, they couldn't be perpendicular to both lines.
Yep.
So you have to get rid of perpendicularity between horizontal and vertical as a natural conclusion for this thing. But
yes,
that's the very thing about the parallel postulate, as they call it, the triangle axiom.
Yes, and they don't use that. They never say that a plumb line is not perpendicular to horizontal. I don't know why, but they never say that.
Because it sounds ridiculous, doesn't it?
If I understand this correctly, in essence, what they're saying is, Ev, you standing where you are and me standing where I am in New York, the mileage is greater between our heads than it is between our feet.
Yes.
That's what they're saying.
Yeah.
Holy shit.
Mm-hmm. Yeah, and they're basically saying that there are no parallel verticals and there are no parallel horizontals, or that horizontal and vertical aren't straight lines, or that the perpendicularity aspect of horizontal and vertical. Basically, they're saying everything you understood about geometry and straight lines, just imagine something different. They're not that. Just go into non-Euclidean, but use Euclidean principles to get you there. It's just so flat earth society, this whole thing. It's just confusion. The whole lot. There's no logical system for you to fall back on if you go with any of this at all. Madness is the only conclusion from going along with what this guy's saying right here. And a lot of people won't want to hear this because this is the basis of all of their understanding. They've got Jesse Kozlowski and this guy. There's no one else. They've got nobody else other than, well, Bob Nodell, he's done some stuff, and Jaren's done some stuff, and Chaiki said that he's got a picture from a YouTube video that he said that I've proved something as well. And these guys have got fuck all. They don't even use these because these are just lying. This is unbelievable. How there's no mathematicians coming round here to prove this. There's nobody in reality to come and say this sort of stuff because it's literally impossible. I felt slighted just because these guys were trying to do it to me, but they've been doing it to flat earthers. They've been doing it to everybody that asks a question, and their only response is that you don't understand it. It's you. Yeah, well done, Skeptic. Yeah, these guys showed me the way by saying they were calling me horrible things. They made me research it, and that's what I've done. So the reason I've been doing all of this over the last few years is to learn. And now I'm ready. I know every one of their tricks inside out. The psychological tricks, all of it. I've watched it all. Flat Earth Society have got a lot to answer for. They're not going to answer for it because they've all run off. They're not around anymore. This guy, the guy who probably doesn't live in Maine, and Jesse Kozlowski. This is the Jesse Kozlowski's protege. This is his Facebook friend from Maine that he spoke about in the Soundly thing where they were measuring when he drove over a bridge for Soundly. Carry on.
And we can see that they will. And then over here, if the Earth is curved, the plumb lines will converge under the ground.
No, they won't.
With altitude.
No, if the ground's curved, you would still be able to measure elevation changes with parallel horizontals. This guy's definitely not a surveyor. He hasn't got a fucking clue what he's talking about, and he's an obvious Flat Earth Society member.
This is non sequitur because shape doesn't follow from measuring plumb lines or horizontals or verticals. It has nothing to do with the shape of the Earth. So this is non sequitur. And of course, secular reasons. So he is assuming anyway the shape of the Earth, which is not true, of course. But now he is trying to convince people that this is why we live on a ball, because he assumes that we live on a ball.
Because he's done 94 degrees. I mean, he obviously doesn't even know, right? To anybody that's looking at this, who knows anything about whatever we're talking about here, this 94 degrees is so fucking ridiculous. It's impossible as a sighted thing. Nobody can sight that far. Even the world record photography is nowhere near these numbers here on their purported ridiculous fucking model.
Like 200 miles, so something like that.
Yeah, well, this is 8 times 69. A little bit further than that, isn't it?
Yep.
Like a lot further. But hey, nobody's noticed. Don't worry about it. Not a lot of people have watched it. How many? There's only 450 views on this. Nobody was bothered about it. Nobody understands geometry. Nobody realizes. Well, perhaps they do. Perhaps that's why nobody watches this. They don't realize how bad this is for the globe model. How ridiculous it is that he's literally stating he's doing the impossible to prove the globe, when everybody should know what that means, right? This guy's a fucking actor. But people are easily fooled. Obviously, I think that's the other thing that comes across. Anybody that states this as a proof has been handed a paralogism, an obviously fraudulent paralogism, because it's messing people's minds up. Anybody that believes anything like this, their mind is broken, because they're literally being handed a paralogism, an obvious untruth. Carry on
the side where
finish.
Well, it doesn't. Yeah. So what we have here is,
doesn't he sound like
angle A and angle B? They're both over 90 degrees here, so you can tell they're definitely greater than 180 degrees, right? This is a graphic to illustrate the principle. Okay, all of these graphics are here to illustrate the principle. And then
illustrate
we have,
the principle.
well, let's stick one on a hill, at some kind of elevation above this one, so they're not equidistant from the center of this curved shape, the radius point, and we find that these two still sum to greater than 180 degrees. Therefore, these plumb lines.
And you can notice that even in his picture, the plumb lines aren't plumb.
Yes.
Not both of these plumb lines are plumb.
So he has nothing to prove because these plumb lines are already divergent. So what he's trying to prove?
Yeah.
Nothing.
They say that these plumb lines are the same. They're both labelled plumb, which would normally, within mathematics, show that they are the same. But they, as you can see, they're not the same, which is, I would say, fraudulent within maths. But hey, if you're talking to people that are ignorant of the geometric principles, then they could go with that, I guess. People like Wally could believe it, perhaps. Take it on as a proof.
Ev, am I stupid? How is he getting different angles at the bottom of the plumb line than at the center of the plumb line? Or what supposedly he calls a plumb line? How can you have 90 degrees there and then 85 there?
See the horizontal that he's drawn on that's sloping. One of them's to a horizontal.
You wouldn't have a 90 at the bottom. If that horizontal line, which wouldn't be a horizontal line if it was sloping, but if that bottom line is sloping up, you wouldn't have a 90 there either.
You can have a 90 anywhere, providing you've got a straight line. You can have a right angle to it.
A straight line meeting another straight line. You can't have a straight line meeting an angled line and have a 90.
For plumb. Well, yeah, it's like if you follow this one here, it's a plumb line, and this is a horizontal. If you go along here, this horizontal wouldn't be perpendicular to this plumb line. So
I didn't see that 90 is going to a different line. I thought it was going to the line of sight line. I'm sorry.
No, yeah, that's the angle to the other one that he's measured.
All right.
It's interesting. Surveyors, hey, surveyors that aren't around here anymore, like bullshitters, I call them. Role-playing surveyors, which is role-playing badly because he's handing on paralogisms to people who probably think that this is real. There are people that have to believe that. This is why we call this the dogmatic globe model. Because these plumb lines cannot be parallel. That's one of the axioms. They're just not allowed to be. So what he's tried to do, this guy, inventively, he's tried to use Euclidean geometry to disprove Euclidean geometry to show that perpendicular lines aren't parallel. Which is fantastic. Have a word with a mathematics teacher.
Lines can't be
see
parallel.
how horizontal and vertical graphs work.
All right, so these are graphics to illustrate the principle. Now I have
it's got graphics.
Several videos. I have 5 plumb lines videos here. Here's a playlist. It'll be linked in the description. I'm going to link Casey's channel in the description as well because I think she has good content that you should be aware of.
See, Casey's channel.
So here's my first plumb lines video. Here's my actual results from 402 looking to 404, and then my angles from 404.
He wrote them down and everything. I think he wrote them down.
And then here's the mean.
He wrote them down. We saw that video last week. He put them down in his little sketchbook, and this time he's put them onto this thing as his graphic. So you can tell that he says he's measured them. He's at least wrote them down. Wrote some numbers down. And you can add them up or you do whatever you want with them. But, I mean, he did show us a picture of a theodolite that he'd measured the height of.
Standard deviation, plus or minus 5 seconds, plus or minus 2 seconds. Yeah, not too shabby. And then let's go on to the next. Hey, they add up to 180 degrees, 0 minutes, 18 seconds. So those angles add up to greater than 180 degrees. Therefore, the plumb lines between 402 and 404 can't be parallel.
Should we mention now that it's impossible to measure to an arc second over the distance that he did that? That we don't know whether he actually measured them. He did write them down in his little book. But, you know, it's completely flawed, but he's going to use Euclidean principles to disprove Euclidean geometry.
I might have missed it, Bev. What's the distance from 402 to 404?
It was 500, 1,250 foot, which is about 500 meters. You know, when we went out to show people what you could see over that certain distance, that was why we went out to show people what you could see over the distance, because it had been claimed that you could measure to an arc second. And we went to show people that that's a load of bullshit. Impossible to do through a sighted optical device. So
these are optical measurements.
Well, he wrote them down in pencil in a book. So there's no cited thing. There's no evidence of them being measured at all. They just wrote down again. They're just numbers, you know. The standards of proof people require, obviously, because they have no proof. They have no argument. They've got nothing other than bullshitting videos. This guy. Absolute bullshit. And he's done these videos up here. He's done these. He's got 5 videos where he claims to do exactly this again. Go over them. Anybody can go and have a look at them. Anybody within this arena can go and see the proof that this guy's lying. Stating he's claiming to be able to do the impossible, but I don't think many people are bothered about that.
And
bullshitters.
They're diverging with elevation. So that's the best part. So
it's the best part.
Here's a graphic representing my actual field measurements, right? Line of sight. This isn't to scale, but nonetheless, we have this principle illustrated. And we see that 402 was at a high.
Oh, there you go. Look, 1,252.14.
By drawing.
Mm-hmm.
He's saying the horizontal line from 402 to 404 are different. Is that why he's identified them differently? Horizontal line of 404 and 402?
Yep. This guy has literally stated that the horizontal line, there isn't one horizontal line between the 2 stations that far apart. This is the equipotential angle of adjustment measurement, actually performed by this guy. I wonder why he's not around.
This is bullshit, though.
Absolutely. There's a video, it's been there for 2 years, that it's always been there. Because you've not been involved in the geometric argument, and this video wasn't made for you, perhaps, because you were talking about geometric principles and the fact that perpendiculars prove that all perpendiculars to a plane will be parallel. Perhaps you weren't involved with it and you didn't notice that the obvious character that they put into play, namely Jesse Kozlowski and this guy, the main surveyor, complete and utter frauds. They're not surveyors. You cannot do the impossible like these guys claim that they can. This is why this is called the dogmatic globe model. People don't realize it. It's why everybody gets all upset about us talking about horizontal. Because there is no actual horizontal on the globe model. What this guy's claiming he's doing here is ridding the horizontal from surveying. He doesn't realise it. He doesn't understand the principles of what he's talking about. But yeah, he's going against the fundamentals of geometric understanding.
And still he's mistaken, because if he's plumb to his horizontal at both locations like he's claiming, the angle's not going to change as you go up the plumb line. It's going to stay 90 degrees.
He says they're diverging.
higher elevation.
Dogmatic model.
404. So we stuck it just a little bit up just to illustrate. Remember, it's not to scale. It's to illustrate what was happening. The important part here is we've added up the angles. And they are greater than 180 degrees. So these plumb lines can't.
It's a bit of a trend at the minute, adding up angles to get more than 180 degrees. Just ask around in any of the chats. It's a hot topic. People will ask you to add up angles. Blue will ask you to add up angles. It doesn't prove that verticals are not parallel, adding up angles. If you come to the philosophy tomorrow, Wednesday, you might get a hint on how proof is actually formed within the mind rather than by adding up numbers. It's not as mathematical as you think. It's not about adding numbers up.
Can't be parallel. If we understand the postulate, right, and we understand addition. Okay.
He says if we understand the postulate, well, perpendiculars are 90 degrees, and if you put two perpendiculars to a line, you will have two 90 degrees. So if you understand the postulate, you would understand the postulate.
Yes, and we would understand that he just screw up this measurement because he couldn't measure anything in a proper way. So he had to screw it up, and he did. And this screwed up measurement, he is showing us his proof for plumb lines being not parallel, which are obviously are.
But this is, again, this is the best globe proof. Obviously not a proof because they haven't got proofs. They haven't even got an argument. There's nothing to come with this as in form of a geometric argument. More like an impossibility when you work through it per first principles. All you have to do is understand the relationship between the plumb line and the horizontal perpendicular until somebody who has a dogmatic globe model intervenes, and then they'll start telling you differently like this. But what this is an impossibility, a geometric impossibility. I don't care what anybody says. The relationship of horizontal and vertical being perpendicular makes this, what this guy's talking about, an impossibility. There's no way you're getting around it. None at all. Geometrically, mathematically, logically. Real proof.
And then I want to point out, I've done this several more times.
Done it a few times.
So I went to another location in Maine. So that's another thing, right? So if plumb lines aren't parallel in one spot, they must not be parallel in another. And I went to another and just randomly picked two spots that were fairly far away. And let's see. We go through results. Hey, the sum of those angles is...
Look, he just showed you a picture of something on a road. And bish bash boss, look at that. Boom, he's got some writing again.
Yes, this is a result.
Yeah.
Magic.
Yeah. Absolute bullshit. Absolute
is
bullshit.
Greater than 180 degrees. Therefore, the plumb lines in Rumford are not parallel.
Again, how can somebody just say that? How can the globe earthers must be absolutely furious at this guy. I would be. But you can't call him on it. Nobody can call it. He's like, he's got everybody on the globe side by the butt of calling their bluff. He said something ridiculous, But he has to be able to get away with it. Because if anybody says, no, that's a load of bullshit, you'll just go, you're a flat earther. Not like, oh, you might have a point there that you know, the logic isn't sound. The geometric principles isn't sound. And the earth obviously isn't flat. No. They just call people names and that's it. Be done with it.
And then I did those Rumford.
There is no arguments.
Plumb lines, measurements.
Just
3
bullshit.
more times after this one.
Done
We
it
got to
again.
be rigorous, right? All right, so that's what's going on with plumb lines. So these are the print. We got
Right. This guy has got here with the sum of means. He's got 180 degrees, no minutes, 17.1 seconds. 17.1. Now, we already proved that over that distance you can't measure to the second. So how do you get a 0.1? You're bullshitting. It's like NASA. They leave that shit there so you know they're not telling the truth. He'd be able to say, well, I'm obviously, I never showed anybody I was doing it. And I've wrote it down there, that ridiculous numbers. I mean, nobody could actually take me seriously when I was saying this. I'm a character. It's a YouTube character. Playing the game. It's just a character for the globe model. The dogmatic globe model. Not the real globe. And the dogmatic globers can't call him on it.
got to be rigorous, right?
It's got to be rigorous.
All right, so that's what's going on with plumb lines. So these are the principles that are going on behind here, right?
These are the principles, right? These are the principles that they cannot talk about, strangely enough. Yet they're the principles that are going on behind this. But they can't talk about it. And they can't talk about it because the principles prove this guy's a bullshitter. Obviously. Nobody can come and talk about it. They must be hellishly embarrassed. And anybody can tell anybody that. I will talk to anybody about this. Bring on the best globe geometer. There isn't any. Bring on the best globe surveyor. There isn't any of them either. We're just here. Simple group of people that people have bad-mouthed. So nobody wants to come and talk to us, but wait to see what's coming. I like this guy. This is where I came in. I was talking to these guys on Twitter. The Casey. I was talking to Jesse Kozlowski. I was talking to this bullshitter. There was another one called Aaron Burrell that used to pretend he was a surveyor. There was a guy called Howard Moore that I knew on Twitter ages ago. He claimed he was a surveyor. There was a big time when everybody used to claim that they were surveyors because they liked to be able to think that they could do geometry. Not realizing that surveying is the practical application of Euclidean geometry in reality.
We've talked about, and there are several graphics in this whole set, and the important thing to note is when we actually measure these things, the results that we get match only one of those models. Only one of those models bears out in reality, and it is the convex surface.
Not the Euclidean model, strangely enough, even though he used Euclidean principles and Euclidean. That's really weird.
As in
I
the
don't know how we
outside of a
came to
spheral
that
shape.
conclusion.
All right. So
almost as if it was
if
circular
you have
reasoning.
measurements that refute this, that's what we would need to see to show that plumb lines either are parallel or converge above our heads.
So he says if you have measurements, like I said back in the day, there is definitely a measurement that you can make for horizontal and vertical being 90 degrees. Then all you would have to do is to establish a horizontal between the two. Okay, does that sound good?
Between two, you say
Verticals,
verticals.
plumb lines. Yeah.
Yes, of
Okay.
course.
So that's all, literally all that anybody needs to do is to establish a horizontal, and at either end of the horizontal have a plumb line that is perpendicular at both ends of a horizontal. So establishing a horizontal is the only thing that's needed to be done first. First off, question 1, can we establish a horizontal from A to B? And how long would that horizontal be for everybody to be okay with it actually being a horizontal? That's it. Simple question. Ask yourself. And then hear that little voice in the back of your head that goes, Euclid test. That's what the purpose of the realizing Euclid test was. Always has been. These guys here are talking bullshit about geometric principles in reality. The realizing Euclid test is exactly that. For you to realize the geometric principles of Euclidean geometry in reality. The simplest way possible. Have a go at whatever test you want. But that's what we're proving. Geometric principles in reality. For everybody to get a grip on. For everybody to understand what mathematics is in reality. It's not difficult. Anybody can do this. The proofs are all mental. Actually proving it, doing the test, is all about how well you've done your proofs beforehand. Can you replicate that proof? Right, let's go back to the... Okay, so... back onto this one here. How did we get? Oh, but we get quite a way. This is going to carry on now because this gets even worse. It was like a recapping of all of the stuff that we went over. Anyone that can't immediately answer. I said, I'll be presenting the Realizing Euclid test as a series of mathematical tests and proofs based in reality. I'm just putting it all together, which I am. It's coming soon. I'd like to get your opinion on the horizontal paradox and how you, as a mathematician, deal with the contradictions you find. And Casey says, Bev, can we agree that the surface of a sphere is not a plane? Can we also agree that area is a two-dimensional measurement? And I said, a plane is 2D. it doesn't curve. I don't imagine that a two-dimensional plane can curve around a sphere. In fact, I've written some logic especially to express my argument. Which is here. Modus ponendo tollens, if anybody knows that. It's a mixture between modus ponens and modus tollens. And it states, the mode that denies by affirming. Modus ponendo tollens is written in the form 1. Not both A and B. 2. You state A. 3 is therefore not B. For example, this is where I give an example about this. It states, both a circle and a sphere cannot be 2D. A circle is a two-dimensional figure. Therefore, a sphere cannot be a two-dimensional figure. And Casey says, your first statement both times is incorrect. So the first statement is not both A and B. That's incorrect, says Casey. Law of non-contradiction violation, but a circle and a sphere can both be 2D, says Casey, through conventional use of the word and mathematical use of the word sphere is different. In mathematics, sphere refers to just the surface of a three-dimensional figure. The three-dimensional figure itself is referred to as a ball. The surface of any object has no depth and is therefore two-dimensional. If we are getting really technical, a circle is just the outside of a disc. It is a one-dimensional object, as the measurement of such requires only length. These may be definitions that you are unfamiliar with. Your ignorance is not my problem, but I'm confident others have informed you of these concepts and you still choose to ignore them. Willful ignorance is definitely not my problem. So is everybody up to date on that? You have to remember, this is a geometry teacher from Canada that's telling me this. If everybody's okay with it, then that's fine. But I'm not okay with this. I mean, I was ignorant of it. Like, look, a circle is just the outside of a disc. It is a one-dimensional object, as the measurement of such requires only length. Everyone all right with that? I mean, you can have Casey call you ignorant to it as well. Willful ignorance. You've been told it now by Casey. I've read it out. All of you people have now heard it. Wally, she's not a teacher. Come on. This is getting fucking ridiculous. This is getting really ridiculous now. I say, why have you reimagined the foundations of mathematics? What allows your mind to do that? Help me understand how you let your mind do that. Teach me. Casey says, I haven't reimagined anything. There are numerous branches of mathematics that all have their own set of rules and their own practical uses. Nothing allows my mind to do that. I've simply been educated on their existence and their logical conclusions. You have an elementary mathematics understanding. What you are taught in public education is just the tip of the iceberg of human understanding. Well, we're into metaphysics, so I like to understand this, and I particularly like to understand the minds of teachers, because I'm really curious now. I'll be Wally's known Casey. Well, that gives you everything you need to know. Wally has known Casey for years. Public education. I say an angle is one inclination of one straight line to another. There are no straight lines on the surface of a sphere. Your stolen concept has already been noted. You can't think that I'm that stupid, can you? Casey says, once again, you are using a very basic understanding of a concept. There are straight lines on a sphere. They are just different than those on a plane. It's not a stolen concept. It's a mathematical definition that has been utilized by humanity for hundreds of years. It's sophistry, that is, I think she's talking about.
Yes, they are different. So how they differ from straight lines?
You can't say they're different. Like the way the difference works within a definition, you state what they are that have the same, and then you state what's different. They don't have that. They're just different because mathematics.
Yes. So if they are different, so they are not the same. So they are not the same straight lines. So they are not straight lines.
Just sort of waving a magic mathematical wand around and say, poof, they're the same but different.
Yes, but she said before that they can. Now I realize that all of them, they are not saying that they are different. They can differ.
Uh-huh.
So they are doing this possibility. This is not statement 0-1 logic. This is statement that they can. So we have instances where they say that there are instances where they are straight, and there are instances where they are not straight lines. So this is bullshit. This is sophistry, because you cannot say that straight line can be not straight line.
Yeah, that's the thing about the sphere, is there are 0 straight lines possible on a sphere. A sphere is a surface of constant curvature. There's no place where a straight line could possibly be. So this is where the sophistry comes in, right? And the inverting of reality. These people are just literally trying to get you into Alice in Wonderland by inverting what is and just saying, no, not that.
Because on the surface of cylinder, you can draw a straight line only in direction along the axis, let's say.
Mm-hmm.
so you can draw, but on the sphere, you cannot. It is just impossible. So when we stated impossibility, that statement that straight lines can be different on the sphere, but still straight lines, it is impossible. It's just impossible. So this statement that on the 2D, when she said that circle can be 2D and sphere can be 2D, no, cannot. It cannot be. So this is just a false statement. Circle is 2D and sphere cannot be 2D. This is simple.
Mm-hmm. So then says, and yeah, and I actually do think you're rather stupid. It must be to be able to think that they can pass something like that past us, right? So I say, your stolen concept is a violation of mathematical thought. I guess that's the difference between our thought processes. Who exploded your logical system? Was it the education or the model affliction you gained within the Flat Earth Society? Because it's different, right? I can't understand why people think that you can have a straight line on the sphere when it's pretty obvious that it's definitely not straight. It's one of those things that has got me. It must just be, I think it's to do with the model affliction, which is where we're going to be going in a bit, as to what holds your thinking and your thought processes and stopping you from exploring certain areas. What exactly is it that does that within the mind, obviously? On this one, I say, solid geometry with the sphere is defined in book 11. You're not getting most of the conversation because I think half of the stuff is a bit boring, but you don't need to hear my stuff because you'll have heard it all before anyway. Solid geometry within the sphere is defined in book 11. Have you ever practiced geometry at the foundational level? I'm genuinely curious. I know you've misunderstood me from day one. You know I'm not a flat earther. I have proof it's not flat. Let's talk about this. Then Casey says, Bev, whether you want to call yourself a flat earther or not, that is what you are. So these are the people that we're dealing with, right? You believe that verticals are all parallel in reality. I do believe I've only ever stated that horizontals are parallel and that all perpendiculars to a horizontal plane will be parallel. Make of that what you will. That can only happen if the core geometry of reality were flat. In actual reality, verticals diverge. I'll state that again. You believe that verticals are all parallel in reality. That can only happen, this is a logical conclusion of Casey's, that can only happen if the core geometry of reality were flat. So the core geometry of reality, according to verticals diverging, is what? What's the core geometry of reality? If we can't have verticals being... I don't think Casey knows.
This is bullshit.
Yeah.
Non sequiturs.
Yeah. It's people who are obsessed with flat, yeah. Like anybody that puts flat into a conversation, obviously Flat Earth Society. I don't care about it now. People who perpetuate a bullshit just so people don't actually have to have an actual argument or a discussion about something is ridiculous. It needs to end. So I say flat is not a geometric term. It's not. It's got nothing to do with geometry. Perhaps you're more afflicted than you realise. Have you considered that you may be unwittingly influenced by the Flat Earth Society? You are using their useless terms where they're not needed. And that's going to be a regular response to most of my stuff, because, like I say, I'm not a flat earther and I don't give a shit what you think what model is. There is only reality. That's all we're talking about here. And I'll debunk all of this bullshit all day long. But it's not for the flat earth. It's for reality. Casey says, no, Bev, it's not a stolen concept. The surface of a sphere is different than a plane. It needs different rules. For instance, the distance between 2 points on the surface, capital letters, is different than if you cut through the solid itself, but both can be calculated. Weird statements, mean nothing really. Sounds like she's trying to back out of it a little bit. I say shortest distance in reality are measured either horizontally or vertically. Remember the horizontal paradox. This is where your stolen concept rears its ugly head again. The antiquated dogmatic globe has many contradictions. The real globe is where it's at. Try thinking. So that's what we're at now, right? Who's with me? We're selling the real globe and we're going to put it up against the dogmatic globe. That's where we're at. Proofs in reality versus dogma and bullshit and impossibilities and fake people. Casey again. Here we go. No, Bev, that's just foundationally incorrect. Even in Euclidean space, shortest distances are rarely on the horizontal or vertical. The shortest distance between 2 points is a straight path from one to the other. If you are confined to a surface, that path may be straight in 2 dimensions, but have a curve in the 3rd. This is a straight section of a highway, but it's not flat or level section. Straight. You see the white lines at the side? Are they straight?
No.
No.
The road is not straight.
It's not straight. So, like, literally a picture of a not straight road, but saying that, look, that's straight. Visual images like this mean absolutely nothing, but it does go to show how fucking ridiculous they are. About not, like, turning your steering wheel, but understanding what straight is. These guys are ridiculous. It's a joke. I say that's not straight. Just look at the white lines at the side of the road. What happened to the law of identity? Because that's what you're dealing with here now, right? Within this. It's what we're talking about, right? We're talking about the most basic concepts. This is why I'm so lucky to have been here around these group of people. Found the foundations of geometry and then found the foundations of logic. And Raven gave us the trivium. Trivium and the foundations of that teaches you about the law of identity. It's at the most fundamental thing you can even imagine. Straight isn't not straight. That's not how the law of identity works. It's a law of identity violation. At the most fundamental level, we call it an oxymoron. Put but metaphysics, that's what the realizing Euclid tests are for. Maybe you are influenced by them. Casey put, oh, that sounded like a bunch of gobbledygook. I wonder whether I put them the wrong way around. Casey says, your definition of level only works over short distances. Over longer distances, it's clear that level curves with the surface of the Earth. I say the dictionary definition doesn't work. Have you informed the dictionaries of this? Have you informed physics about the equal altitude being a horizontal condition yet? Casey, yes, the geometry of the surface changes. Draw a triangle on the surface of a sphere. The three angles don't add up to 180. That's what they've been doing on the other servers, been adding angles up to more than 180. Because it's a spherical triangle, says Casey. It still has three sides and three vertices, but it's something different than those drawn on a plane. A triangle, a different triangle. Law of identity violation, don't worry about it. Casey's a mathematics teacher, geometry teacher at schools in Canada. This is a straight line on the surface of a sphere. Straight in two directions, curved in the third. Isn't that weird?
Straight line is straight in all directions.
Mm-hmm.
So in all dimensions, rather.
How many dimensions does she have on the surface of a sphere?
3.
2. It only has 2. That's how we started this off, the surface of a sphere. You'll go back to it in a bit, but in this one, there's a third one. There's 3 dimensions, and we've just, boom.
So this line is curving in that dimension, which is not present.
Yeah, the one
in the sphere.
See, the one that's curving. Let's just get rid of that one. Yeah,
let's
pretend that
just
one's
ignore.
not there. Yeah.
Yes, just ignore this third dimension, and then we have straight line.
We'll go back to it again, right? But just remember this. Straight line on the surface of a sphere, straight in 2 directions. I don't know which 2 directions it is. Curved in the third. Maybe meant 2 dimensions. Not directions, but although it's the same sort of thing, isn't it?
Yes, because dimension is measurement in one direction. This is definition of the dimension.
Yeah, but what do you reckon the direction of each way of a straight line? Like a straight line only has 1 dimension, but it's got it being straight in 2 directions and curved in the third. It's like 3 directions of a straight line. Mathematics teacher. She's only a Canadian geometry teacher, but I mean, how ridiculous does that statement sound? I mean, what made her say that? So I say that. So there is 3 dimensions. Then, can you see your contradictions yet? And I don't know whether it changes. So there is 3 dimensions. Can you see your contradictions yet? Casey says it's not a contradiction. A solid has 3 dimensions. Its surface has only 2. So when a line is straight in those 2 dimensions, it is straight on the surface. It's curved in space. It's not a contradiction to completely dismiss the one dimension that it is curving in their understanding, which leaves two dimensions that it's not curving in, but those two dimensions are the plane?
That would be, but she already killed her argument, because when she said that this line is curving in third dimension, so she killed her argument that a sphere can be two-dimensional. Because how can line drawn on quote unquote two-dimensional sphere
It's not though,
can
is it?
curve in the third direction?
Yeah, it's when Casey says it's straight in two, what Casey means is it's on a plane.
Yes,
Right.
I know.
Okay, so
yes.
the circle, right, that obviously that's in a plane that's generated, Casey wants to call that a straight line. She wants to call a circle a straight line and say it's not curving because you're looking at it edge on the plane. It's so bad that I'm not too sure whether they'd listen to it, or if they've listened to me, they might have an idea. But I mean, you literally have to turn a straight line, a one-dimensional thing in Euclid, into a two-dimensional. Even Casey says it herself. Added a dimension to a straight line to make it 2D and say it's not curved when it's actually a circle on a two-dimensional plane.
Maybe yes, but still she's killing her own argument. So
yeah, absolutely. There's not even an argument to start off with, right? If there was one, it ended the moment
claim.
she
She claimed that surface of the sphere can be 2D. But then, now, she said that line, straight line, is straight in two directions, but it is curving in third direction.
Yeah.
So she admitted that the surface of the sphere has three directions, not two. So it is not 2D.
Yeah.
So she killed her argument or claim that sphere can have two dimensions. It cannot, with her own admission.
Blatant contradictions within their own argument. Oh, well, I don't know. Just do you reckon it's ECV, whether they can do it to themselves, right? Just completely dismiss the one that's curving in, even though they literally just said it is curving in that, and then be able to say, well, let's just pretend it's not there. Like, do you reckon it automatically happens in their own mind? They can just get rid of it.
This blown mind. She just, I think that she just forgot what she wrote above. So maybe she should read what she wrote to see this contradiction. Maybe, I don't know, because blatantly she contradicted herself.
So I say a level is a tool for establishing, because I think she said that level and horizontal aren't the same thing. And I said a level is a tool for establishing a horizontal plane of reference. Level is a straight line on a horizontal plane. Which Casey says, over a short distance. Over short distances, we can ignore the curvature of the Earth because it's insignificant.
Like this is like ignoring topography. It's similar.
Most things humans need and build are at a scale where the curve doesn't matter. That scale is 1-to-1. That's the scale where the curve doesn't matter. Actual reality. Admission by Casey. The language we use does not create our reality. Absolutely true also. But that's a nice admission, right? Most things humans need and build are at a scale where the curve doesn't matter. And all things that humans build in reality are at a scale of 1-to-1. Reality scale. Actual scale. Now, they may represent something in a different scale model when you're doing that, but everything in reality is at a scale of 1-to-1. Its existence is sort of the law of identity within that thing. That's the scale of the thing, the object. That's it.
So it means that there is no curvature in reality.
Yeah. Admission by Casey. That's good. But I mean, it is only Casey who's purports to be a Canadian mathematics teacher, but that's not very good authority. So when Casey says there's no curve, I don't know whether you could trust it or not. So like, still look for yourself. Don't rely on what Casey says for anything. I say, so we agree. Level is a straight line on horizontal plane, and the difference is that I say the straight line on the plane doesn't scale into a curve, whereas you imagine it does at some scale. I don't know. Can you present an argument for your case? Because this is the realizing Euclid test. I keep trying to tell everybody the importance of the realizing Euclid tests, and we've already done it. And then I say a video of Spaghetti Boy where he's talking about his Bob the Science Guy water level hat that Bob designed. And Casey says, the argument for the globe is the same as it always was. Observations and measurements show that vertical lines diverge from each other. As we've just shown from the lying guy that obviously isn't a surveyor, and we don't even know whether he lives in Maine or not, because he's fucked off. He's never going to come back. He can't explain the bullshit he's been talking about. He wouldn't even bother commenting on the video because he's literally, he's gone. He's never coming back. Level ground is able to obscure the view of objects that are above it. I don't know what that means. Sounds like fantastic. Level ground is able to obscure the view of objects that are above it. Those observations require that the surface is curved.
Nobody is taking observations, making observation and taking measurements from the surface of Earth. So this is just another nonsensical statement.
Casey says, establishing a plane on the surface of the Earth is usually done over a short distance. Over short distances, the curve of the Earth is not significant enough to worry about. This is not a paradox either. I'd say it's not. You don't ever worry about the curve. Especially making canals and stuff like that. Any building projects. Nobody ever bothers about it. Even all elevation profiles. They don't worry about it. Don't bother about it at all. This is where we came to. Did you want to say something?
in geometry, it doesn't matter. It is if it is significant or insignificant.
Yeah.
It is or it is not. This is very simple. Straight line cannot be straight line if it has insignificant curvature. Because if it has curvature, it is not straight line. It doesn't matter if this curvature is significant or not significant. If it is not straight line. So saying that something is insignificant, it doesn't matter. It's just the difference. This is special difference between lines. Straight lines differ from curved lines. And this difference is not about significance of curvature. It's about curvature itself. If curvature is present, the straight line is not straight line. Simple.
Yeah.
Not significantly not straight.
So, KC says, and this is what you'll be glad to hear, I've already provided you with the links you need. This isn't imagination, Bev. It's tried and true geometry. To which KC comes with spherical geometry. The 5 axioms for spherical geometry are... Now, go with this, right? They may sound a little bit familiar. So, number 1. Any 2 points can be joined by a straight line. Does that sound spherical to you?
No.
Okay. Number 2. Any straight line segment can be extended indefinitely in a straight line. Does that sound spherical to you?
No.
No. Okay. Number 3. Given any straight line segment, a circle can be drawn having the segment as a radius and one end point as center. Does that sound spherical to you?
No.
No.
Okay. All right angles are congruent? Equal.
Yes, they are.
Okay.
No, this is not non-spherical.
Okay, that sounds like spherical. No. What about this one? There are no parallel lines.
This is non sequitur from previous statement.
Well, it's not even a non sequitur because the very existence of a straight line means there has to be parallels.
Yeah.
Yes,
You can't get rid of parallels if you have straight lines. So I'd say of that, none of that's actual spherical geometry, right?
Yes, and the last one is how to say that this is impossible.
Mm-hmm. The only way that could be possible is if there are no straight lines, right?
No, I am saying that this statement is impossible.
Mm-hmm.
Yeah.
Because if she's saying that, or this site is saying that there are no parallel lines, so of course they are, because I can draw them at any time.
Exactly.
So I know that this is a lie, just a lie.
Mm-hmm.
This statement is a lie, a blatant lie.
Yeah, because you would have to get rid of straight lines, all straight lines, because the very existence of a straight line would mean that you could have a parallel to it, right? So you have to get rid of straight lines. And can you get rid of straight lines? No.
No.
Bullshit, right? So anybody that goes with any of this, quite clearly, it's not you that doesn't understand geometry. It's the fact that none of these things actually are possible. Impossible they are, really. They're just basically Euclidean geometric principles that they've just changed one of them and said, Well, actually, they've changed the one that our fake surveyor, the lying guy earlier, the one that he used and one that Wally used. They've just literally changed that and said that one doesn't exist. Triangles don't actually exist anymore.
But still, if the spherical geometry is saying that there are no parallel lines, and as you said, if there are no parallel lines, therefore there are no straight lines.
Mm-hmm.
But all previous 4 points are about straight lines.
Yep.
So this fifth statement is killing previous 4.
Yep.
So it means that there is no spherical geometry.
Yep. That means that all of these, every one of these axioms of spherical geometry are bullshit. They don't exist. There is no spherical geometry. It doesn't exist. It's not a fucking thing. Darren said that they've just redefined straight. Darren, a load of bullshit. You can't redefine straight. It's a law of identity violation. Just bullshit. Unfortunately, and especially seeing as that all right angles are congruent, you need straight lines to be able to have a right angle. Again, it should be basic foundational stuff, but there are a group of people, we call them dogmatic globe earthers, that just basically are stuck to a model, and that model uses principles and axioms that just don't exist. The figments of their imagination, literally, provably, mathematically provable.
So Bev, are you just denying that spherical geometry is a thing, right? That
it's definitely not a thing. Yes.
Why?
Because it's not a thing. It's obviously not a thing. Geometry isn't a thing. Geometry is a thought process. It's a mathematical object. Live in thought.
Spherical geometry is the same. It's just a different thought process.
So it's not a thing then.
Straight.
Not a thing then.
It's no different to ordinary geometry. All things like straight lines are just abstract concepts that have some application.
Straight lines aren't abstract concepts. I'm sorry.
It is. It's just someone is saying this is what a straight line is. It's the word straight has no meaning other than within that context, right? It's the same in spherical geometry. They just use the word straight to mean a different thing.
No, that's not the way it works, Darren. Sorry. Go on, paper.
No, I am just saying no. This is false statement. The straight line cannot have different meaning than straight.
This happens all the time in various fields, right? If you want to come up with a way of describing something, you use terms that are familiar. And so in the case of spherical geometry, they've used the term straight as the description for a great circle. It's not straight in the classic sense, in that the XYZ deviation is 0, or whatever the mathematical definition of straight is. In spherical geometry, it's just a different concept, and they call it straight, but it's not the same as a straight line in planar geometry.
So it means this concept is changing meaning of the words.
Exactly. That's right. So you cannot correlate a straight line in spherical geometry with a straight line in plane geometry and expect the things to be the same between them. And this is the mistake you're making, right? You're trying to say, oh, this doesn't exist because in plane geometry, a straight line means this and perpendicular means this, and these are the properties. But the term straight in spherical geometry is not the same as straight in planar geometry.
So it means
it's similar, but not the same. The mathematical definition is different.
This is not similar. This is just different, and it means that we are speaking 2 different languages.
Exactly, simple. 2 different languages. Perfectly described. That's the core problem here, right? It's 2 different languages, but the words are the same.
Yes, but there is a problem, because in Euclidean geometry, this language does make sense. But
And it makes sense in spherical geometry as well.
Spherical geometry is
then try and make it make sense in both geometries at the same time.
no. I am talking about spherical geometry in which nothing has sense. Nothing.
It does. It works.
And Beth just brought this citation from this spherical geometry site or whatever.
No, that's Casey. Casey, the mathematics teacher from Canada, gave us that. Are you okay with those? Is that all right with you, Darren? Are those
which ones? Beth?
The axioms of spherical geometry that Casey gave us?
I think
Twitter.
They're okay, but it's the same deal, right? Straight. The word straight there is not the same definition as straight in Euclidean.
It doesn't say that. No, you can't do that. Where are the definitions of spherical geometry then? Let's see. Let's see the definitions. If you're going to go along with that and say those sort of things, talk about terms, where are the terms wrote down, the definitions for spherical geometry? So we can all understand what your meaning of straight is. Because we all know a Euclidean geometry, right? Now, this is a not Euclidean geometry, isn't it? Or, I don't know, what are you going with? Are you going with the definitions of Euclidean geometry? Because we've got them.
So spherical geometry's got its own definitions, right?
Okay, where are they then, please?
And
Can we have
spherical geometry?
Can we have a look at the spherical geometry definitions, please? Of specifically of a straight line.
Yep. Here's one from Wolfram. Do you want me to cut and paste an image, or?
Yeah, if you can put it in the chat.
We would rather like a definition, not pictures. Because as or spherical geometry is changing meaning of the words, we would rather stick to words, not pictures, because pictures are not definitions.
Okay. So that's from Wolfram Maths. So they're saying that in spherical geometry, straight lines are great circles. So the term, when they talk about a straight line...
It's a circle.
Yeah, but they're just using the term straight line.
But do you not think that's confusing if you actually mean in circle? Why do you say straight?
It's not confusing because you switch context, right? You say, okay, we're no longer talking about planar geometry. We're talking about spherical geometry.
Okay, so are then all circles straight lines? Because if we go back to...
No. Only great circles are straight lines in spherical geometry.
Okay. So when says...
They are formed by an intersection of a plane through the center of the sphere and the surface.
Ooh, so it's like we've gone a long way. When it says spherical geometry number 3, there's no provisos put in here. It says, given any straight line segment, a circle can be drawn having the segment as a radius. So that straight line that you're talking about, the one that's a circle, that can be a radius as one endpoint as the center. So does that make sense?
It doesn't, because a radius is Euclidean straight line, not curved straight line.
Yeah, but it says you can have the great circle as a radius. So can we have the great circle as a radius on the sphere? Like you say.
I can't see this on the screen at the minute. Can you show me what you're describing? You're talking about it.
It's on the thing. It's I'll get it and bring it in to the live chat for you. There we go. There you go. That's Casey, who we were obviously talking to. This is the Canadian mathematics teacher, geometry teacher, the guy that may or may not be from Maine, that definitely isn't a surveyor, said. He called her a geometry teacher. So these are the 5 axioms, right? You know how important axioms are, don't you?
Yeah.
Okay. So you said that a straight line, is a great circle, right? And then it says in 3, given any straight line segment, a circle can be drawn having the segment as a radius. So you said a straight line is a great circle.
Yeah, so this might be confusing. They might be talking about a radial. I'm
What,
not
a
quite
confusing
sure.
axiom?
Yeah.
Are you
so
sure?
The axiom, the wording might be confusing there. I'd have to check that one. Yeah.
But it is already a circle. So how can you use a circle as a straight line to make a circle, to draw a circle?
So they're talking about a straight line segment, and that might have more specific definition, like a straight line.
Is it a straight line segment? A segment? Are you saying you can use a segment of a great circle as a radius? Because radiuses are straight, aren't they? Or have you got a redefinition of a radius within spherical geometry? Have you got that? Give us that one. What's the redefinition of a radius?
I don't know.
Because that's a straight line, isn't it? Like a real straight line, not a radius, great circle straight line that you've redefined.
Yeah, I'd have to see a diagram or something.
Got a problem there, haven't you?
Wording for me is confusing.
Because there are no straight lines. So how can you use a...
No. You're making that statement.
What?
That there are no straight lines, right?
But you've said that a straight line is a great circle. You said that. You were the one that said that. Straight lines are great circles.
Yeah.
Okay.
But there may be times where they refer to a classic Euclidean straight line as well, right?
What, within the axioms? No. You can't. You can't revert back to a not straight line because you've redefined straight lines now to be great circles. This is mathematics.
Yeah, but
but there's no buts in mathematics, I'm afraid.
Summary, right? Euclid wrote 11 books to describe his geometry. You can't summarize all of spherical geometry in 5 points in a
you can't even give the axioms of Euclidean geometry in 5. They needed 15 in my book. So where are the rest of them for yours? Where are the definitions?
All the axioms or some of those postulates as well. But anyway, so you're getting into words.
3 of them are postulates, yeah.
But the reality is
the same 3 ones that you've got there at the beginning, strangely enough.
Spherical geometry, and it works, right? The terms may be contradictory with what
Euclidean geometry definitely works, yes.
Yeah, so does spherical geometry, right? You can use these things.
There's no such thing. It doesn't exist.
Radius doesn't work. Sorry. This is an example where this spherical geometry doesn't work because you cannot create circle. Still, even if this great circle is straight line, it means that you are using curved radius to create straight line. This is just another nonsense.
Can I just ask you again then, right? Let's grant that any 2 points can be joined by a straight line with your new definition, right? Brilliant. We've redefined straight. Axiom number 2 states, any straight line segment can be extended indefinitely in a straight line. Can you do that?
I'll have to check, Bev.
You've got a great circle. Can you extend it indefinitely in a straight line with a circle?
So what you need to do, right, before you chuck spherical geometry out.
No, I'm just asking you. We're just going through the foundations of the axioms.
Detail, right?
Let's go.
It's a bit like flat versus level. You need to understand the alternative before you can throw it out. And you're throwing it out based on direct mapping between
you've got nothing,
Euclidean terms and spherical terms.
No, this is contradiction because if great circle is straight line,
that's crap. It's not a contradiction. Spherical geometry is a branch of mathematics that works. It's mathematically correct. It has proofs and axioms, and it works.
Okay, so riddled with contradictions. It's not mathematical, Darren.
At this point. The second point is saying that straight line in your geometry, it will be a great circle, can be extended indefinitely in a straight line. So the Beth was asking if you can extend this great circle being straight line.
Yeah.
If you have segment of great circle, you can extend this great circle being straight line indefinitely. And Beth asked
except it joins up with itself. That's one of the
So
characteristics of.
you cannot. So you cannot extend
No, you can. It's
indefinitely.
not the same as a straight line in 3D space. A spherical geometry
So you're
straight line.
redefining indefinitely
joins
now
up.
too, are you? To meaning
No,
it
no,
does
keep
come
going
to
round
an
and
end
round
when
and
it meets
definitely.
itself.
It's the same line, but it's This is right. This is the thing, right? Different definitions, and you're trying to use the fact that there are
No,
different
I'm just
definitions
trying to use
to explain
reality and
English
reality
words used in
reasoning.
different ways.
Yeah, you're just talking over the top of it, right? There's no reasoning coming from your behalf here. There's nothing.
The second definition is just saying that you can do things that are impossible in spherical geometry. So this second axiom is saying that you can do something which is impossible.
No.
Yeah, this is
Yes.
only it's only a Canadian teacher that's wrote it. Are you sure these are right? Before you start defending them, Darren. I mean, do you trust KC that much? I mean, Wally's known KC for years. And a guy that obviously isn't a surveyor has said that she's a geometry teacher. So do you really trust her?
I don't know who she is. I'm not putting any trust in her at all.
So do you
I'm
trust
looking at
these axioms
independently.
that she's wrote down then as being the actual axioms for spherical
Yeah, so,
geometry? Or do you not actually know anything about spherical geometry to start off with?
It's been a long time, right?
Yeah, I bet it has. You're just making it
used to
up
know
right
that.
now. It's a bit difficult to be sophist like this with geometry, isn't it?
No. You're the one that's being a sophist, Bev.
I'm not.
By making up lies about terminology. Right?
Come on,
deliberately
Darren.
trying to-
That's pretty
to
bad, mate.
mislead people by.
I'm not misleading
fabricating-
anybody. I'm telling
Yeah,
everybody
let me
they
just-
can make their own
no, no,
shit up
Can
themselves.
you guys give me 1 second? Can you guys give me 1 second?
hmm
I just have one thing to say to this Darren guy. I know you are, but what am I?
Sorry, mate, you're breaking up there.
I didn't get what Rob said.
Your response just sounded so childish.
Maybe, yeah, it's kind of contagious, and I'm getting a bit short-tempered, I guess. Yeah. But yeah.
Darren, do you agree with this second axiom? Let's take this axiom from spherical geometry separately. And I have a question. Do you agree with this second axiom? That if you have segment of straight line, you can extend it indefinitely.
Yeah, so if we're talking about a line in a spherical sense, it can be extended indefinitely.
I'm talking about this second sentence. So this is straight line in your sense. We are now in spherical
which is
geometry.
a great circle, right?
Yes.
So you can extend a great circle indefinitely.
Yes.
You end up going around in circles because it's a circle, but you can extend it indefinitely.
So you cannot extend it.
No, a line of infinite length in spherical geometry continues to go round and round the circle. You know,
It would meet itself. Come on, Darren.
Yeah.
So
it's not the same as a line
in
a straight line in Euclidean geometry, right? It has some different meanings.
So
that's why we can't. Yeah.
So sorry. So it means that in spherical geometry, extending means the same as overlapping. Because this is consequence.
But it's not
extending.
But it doesn't
means,
have the same implications as in planar geometry.
And
right?
I am stating that implication. The implication of spherical geometry is.
So what is the implication of it?
I'm just saying that extending
that's
straight
true,
line.
right?
Sorry. Give me a chance to say to the end. Extending straight lines means indefinitely overlapping.
Yeah.
Okay. So this is just different meaning. Completely.
Exactly.
Nothing to do with a straight line and nothing to do with extending indefinitely. Because if you are overlapping, it is not indefinitely, because indefinitely in Euclidean,
depends, right?
in Euclidean geometry, extending indefinitely, it means that it has to occupy new space, not old space. But overlapping means...
So this is one of the differences, right? Yeah, there's some different concepts in spherical geometry because you're confined to a sphere. So, you can't go off into infinity. There's if you look at a two-dimensional or a Euclidean straight line, right? You can describe it as a function in 2D of y equals mx plus c.
No, it's an axiom. It's an axiom.
As a function of an angle, maybe.
No, this is an axiom. Do you understand what an axiom is?
You cannot get rid of it. This.
Yeah, but the spherical geometry axioms don't have to be consistent with the axioms of planar geometry.
Oh, come on.
No.
You're pretending this is mathematics, aren't you? You're pretending mathematics?
Different set of definitions, right? I could go and define a straight line.
We are not
as something that is not.
Darren, we are not asking about to be consistent with Euclidean geometry. We are asking about self-consistency.
Yeah, mathematical consistency, right?
Yeah.
That within the laws of non-contradiction, the law of identity, just keep them consistent. Let us know what they are within the axioms and then keep them consistent. We've only ever seen one definition. That's all we're dealing with. Your redefinition of a straight line. And then we're dealing with the axioms that you claim are the spherical geometry. We're just trying to keep them consistent within themselves. That's it.
Yeah. No, that makes
right.
sense.
Okay. So
they are, right? But
it's not. I'll prove it to you now. Right? That length, the indefinite length of a straight line segment, right?
Yeah.
How long is it?
It's indefinite.
Okay. Now, take that as an indefinite length.
Segment has a finite length. Yeah.
Okay. So it says, given any straight line segment, so let's take the biggest one, right? As the example. A circle can be drawn having the segment, the longest segment, as a radius and one end point as the center. Is that possible?
So I think what they're describing there is if you've got an arc on a circle
of the longest segment length, any straight line segment. No. It says, number 3, it says, given any straight line segment. So what I'm going to take as the straight line segment is the straight line segment that can be extended indefinitely in a straight line. I'll take that one, right, from number 2, and we'll place that into number 3. And to keep internally consistent, is it possible to use that indefinitely extended straight line as the straight line segment? Well, just take a bit off it. Let's just cut a little tiny piece off it.
Finite length then, right? So a segment, an arc. You can take an arc on the sphere and you can rotate that arc around one end of the arc on the surface and draw a circle. I think that's what that's saying.
No, it says you can use that as a radius. So
given any straight line segment, which is the arc on the circle.
Yeah, the complete arc, right? The complete
radius, and one end point is the other.
Let's take the complete. Let's pretend that extending it indefinitely means just until it touches itself, right? And then let's take that segment as a radius. Is that possible for us to use that segment as a radius on the surface of that sphere?
So if you're saying we had a full circle in that case.
Yes, great circle.
Yeah. Well, the radius would be 0, right?
No, the radius would be the segment, the entire segment.
Yeah. So if you to come back, it's closed. You rotate it around that point. The diameter is 0. That's my interpretation of what that would be.
No, we would take the entire length of the segment that goes all the way from one end to the other.
Yep.
That's your straight line segment.
Yeah.
Okay.
We have a look at it as you approach that.
Can you put that as a radius, as it states in 3? Can you make that segment a radius, having one endpoint as the center.
If the segment is the full size of the circle, Bev, I'm not sure what happens to the definition, right? So
it's not a definition, this is an axiom.
There's probably some...
You're going to go back and change your definition that you just had earlier.
No.
So you're not happy. What does happen to the definition? Nothing happens to the definition. Does it? You can't change the definition because you don't know what happens to it.
Yeah, I think the definition has more to it than just that, right? So it's like in Euclidean geometry, you get a one-liner axiom, but it has some caveats or some further detail.
No, it doesn't.
Right?
No, it doesn't.
And
it has a further reasoning process that you can do.
The straight line segment cannot be the full circle, or it has to be a partial arc.
So number two's gone then, right?
But this is given any straight line segment. Any straight line segment.
Yeah. Okay. So yeah. So maybe they mean any straight line segment is a segment that's not self-closed. But yeah, there'd be some. The term "any" there is probably too broad, right? Yeah. So
it's his axiom, for fuck's sake, Darren.
But this is not the full definition.
You're obviously not mathematical, right?
Axiom is not definition.
It's a simplified definition. What we're looking at in that third term.
No, it's an axiom, Darren.
Come on, let's have a look at Euclid's axioms then. Are any of them
axiom is like a law. It has to happen.
Those
always,
three are postulates.
Without any exceptions.
They're just telling you what you can do within the geometry, in Euclid anyway. Yeah. Obviously, you can't do this in spherical geometry because you can't do anything in spherical geometry because it doesn't fucking exist.
Like you can't do anything with angles, Bev, right?
You can't do
angles, yes. With angles, yes.
Angle.
You can't do many things with angles, but with an angle, just an angle.
Look, I've got to go, but just remember that the axioms are summaries. The mathematics.
No, the axioms are axioms, Darren. You don't understand what mathematics is. You don't understand the basics, the first principles of it. You shouldn't really be here, really. You should find somebody else better than this.
Axiom is a law, or better to say principle, that is independent. This is independent, yes, independent principle. It doesn't relies on other things. So this is axiom.
No, but you might have to clarify it, right? That you might make a short summary overview of the axiom, but the details might be more.
No, you do not do a short summary of an axiom, Darren. Come on.
So anyone who's listening, if I can add, for anyone who's listening, go find, dare you, go find any definition of axiom that includes a summary or shortening or clarification. That is not what an axiom is, despite what Darren wants everyone to think. The wizardry will not work. It just won't work.
Axiom is principle, so it is the shortest, let's say, description of what it is. So it cannot be more short.
And it's not dependent upon a surface. At all. That's ridiculous.
Are just words, and sometimes it's hard to describe the detail in words in one sentence, right? So you can't describe all of Euclidean geometry in 5 sentences, can you? You have to clarify. You have to come up with scenarios and other things that build on that.
These axioms are not really Euclidean. Because axiom is principle of like reasoning. This is logical statement. It has to be logical in first place.
Yeah. So the wording of the axiom is probably too tight here, right? They need to be.
Oh that's what you need to do. You need to mess about with the axioms of spherical geometry. You do, Darren. Go back to your mates. If they're not okay with you, I mean,
right? The geometry works. It's different.
It doesn't work. You can't even formulate the definitions or axioms for it, Darren. You especially. You don't even know what an axiom is.
I know what an axiom is, Bev, but I'm just saying that the wording of it is incomplete, right?
So that's Casey's fault then, right? Exactly. You should have said that at the beginning. Casey's give you the wrong ones. They've got the wrong wording. That's obviously not correct. But you didn't, did you? Why didn't you do that at the beginning?
No, it's not obviously correct. It's complete, right?
It's not. It talks about straight lines. Spherical geometry, there are no straight lines on the surface of a sphere. They're not possible. So redefining a straight line as a circle leaves you with extra problems then, because then when you come to define the circle, you don't have a straight line to use as your radius. And straight lines, a radius is definitely a straight line, isn't it?
So they're defining the rate that, so you can define a circle, right?
You can't use a circle. No, you can't use a circle on this because you'd have to change pi. Because you've got your radius as being curved, a great circle.
Yeah, that's another thing altogether, right?
It's not another thing altogether, because circles are well defined with pi. You've heard of pi, I take it.
I have, but this.
And you're not going to redefine pi, are you?
Pi is a constant, right? But the ratio of the circumference to the radius has different.
It's tau. It's tau, but you've just bent the radius, so you have to change pi. But you don't change pi, so that means your spherical geometry is a load of bullshit.
It's not a load of bullshit. It's a different set of concepts, and that's all.
But you're not willing to go through with all of the consequences of your concept.
And that was it. Right, I've got to go. But
all right, see you later. Good try.
I don't know why.
Let's get somebody better next time, please.
Same way as always, right? Yeah.
Yeah, thank you very much.
Have fun, guys.
Yeah, we will. We'll carry on.
I might come back in a year's time. We can have the same conversation again. That'd be excellent.
I doubt it.
I don't think so. I thought I was listening to a replay when I saw this, because it's the same conversation you've had 50 times.
We've never had this conversation because everybody fails at step one, like you.
Go and do a course on spherical geometry then.
I would say you should go and do that. And when you're doing it, ask them for the definitions and the axioms.
Go for remember, right?
Are you going? Are you going? Let's say what it doesn't. What works? Yeah. You don't even know what you're dealing with for it to work.
That's the pot calling the kettle black. At least I'm prepared to open my mind up to ideas and experiment and explore.
Experiments?
You guys just...
Have you got any spherical geometric experiments that we could perhaps have a go at? Or would you get stuck on a circle? That's a bit embarrassing, isn't it? Getting stuck on a circle within spherical geometry, within the axioms.
You can't even conceive that a circle can be drawn with anything other than a straight line as a radius.
Yeah. Have you heard of pi?
For me, that's embarrassing is with this spherical geometry is that this space is not infinite, because Euclidean geometry assumes...
Don't keep comparing to Euclidean geometry. It's not the same thing. You're trying to say it's invalid because it's not the same as Euclidean geometry.
But this axiom...
Have a good day, guys.
All right, see you later.
See you later. By the way, this word infinite cannot work.
Oh, no.
Because spherical geometry is closed space. So you are just overlapping. So you cannot extend anything indefinitely.
It's the problem within... once you explode the logical system by adding any sort of contradiction within I'd say Euclidean geometry, but it's not. Like, Euclid wrote it down. It is the first principles of reality. You can't break any of these things. And as soon as you do add in an inconsistency, other inconsistencies start jumping up and showing themselves. And it's a problem because you're injecting a falsehood into a perfect system. I'd say Euclidean geometry is the standard. That's the perfection right there. The moment you say not that at any part of Euclidean geometry, you're going to end up with these problems that they can't talk about. It's awkward for them. But well done to Darren. Thank you for coming in, Darren, showing us a model Affliction Monday. We call this the dogmatic globe model because Darren has to have this dogmatic approach to it. I personally have the real globe. That means that anything that happens in reality is consistent with the globe because we live in reality and the globe is in reality. So therefore, anything that happens in reality and is provable within reality obviously goes on the globe. Now, in my globe, I do not have any contradictions. I rid them from my globe. And the dogmatic globers seem to get really upset at the fact that I point out contradictions. And not only me, everybody points out contradictions. But I'm guessing the rest of everybody else has the flat earth tag to go around with. But not me. I don't have a flat earth tag because I'm not a flat earther. Just coming at it from reality. I'm a real glober. The real globe of Bev try thinking. I'll take on these dogmatic globers myself, single-handedly, with just reality. Here we go. So here we go, Casey. My understanding that everything in reality is 3D. Your understanding is wrong. The surface of something is 2D. The object itself is 3D, but the surface of it is 2D.
Did you ask this person if they're able to touch this 2D thing?
Yeah.
Is it tangible? Do they say it's tangible? Because 2D is not tangible.
It's a thing. It's an object.
Can't be. Not 2D. Can't be. It's conceptual.
And she's confusing again. Read carefully what Euclid said about, for example, surface of the cube. He's not using word surface. He's always using plural surfaces. So the sphere is only a solid object that is bound by one curved surface. Other surfaces like prism, cube, or whatever else, he's talking about surfaces, not surface, not one surface. So this is the difference, because you cannot say that there is one surface of cube, and Euclid is not talking about one surface. He's talking about 6 surfaces of the cube. So if 6 surfaces are enclosing a cube or solid object, it means, and this is 3D, of course. No, I would say that nobody will argue that all surfaces of the cube are encompassing 3D object. It means that sphere, this one surface of the sphere, if it is encompassing a 3D object, and it is, it means that it has to be 3D, like cube. Because if surface of a sphere or the ball is 2D, it means that all surfaces of cube are also 2D, and in total, which is not true, because there are different planes. So they cannot be. because 2D means that everything has to be on one plane, and the surfaces of the cube are, all of them are on different planes. So I would say that it can disprove that sphere is 2D.
Yeah. I said it's my understanding that everything in reality is 3D.
Yes.
Hashtag advanced simplicity, right? Just making it as easy as possible. It's a statement of truth, I say. To which Casey says, your understanding is wrong. But my understanding is that everything in reality is 3D. Casey thinks there's some things in reality that aren't 3D. It's the only conclusion you can come to.
Yes.
I'm willing to have a conversation with anybody about these sort of things. It sounds great. So I put that out as another tweet, and a farmer's boy comes along, and he's another one that you can actually, well, I say talk to, but you know, he's around here. He does talk to some people. He has I think a party where he goes gaming with some guys. Slim Cyborg, I think that's his mate. He goes gaming with them. He has a night. So Farmer's Boy says surfaces of 3D objects being 2D isn't a contradiction. This was taught to us when we were at school. You sat the same curriculum as me, because he's about the same age as me. What does everybody think about that? Because I say, I don't want to be influenced by what I say, but I say, don't be silly. The education system would never teach children contradictions. I'll have to look at this. Thanks for informing us. There definitely does need to be looked at, right? If Farmer's Boy thinks people have told him that a surface of 3D objects are 2D.
He said one surface or surfaces?
Surfaces of 3D objects being 2D isn't a contradiction.
Yes. So if he is using plural, yes. So one single surface of the cube, which is square, yes, it is 2D. But there are six surfaces, and they are on different planes. So they cannot be in the same plane. It means that they cannot be in 2 dimensions, because plane has 2 dimensions. And if we are, let's say, horizontal, so we have square, which is bottom of the square of the cube on horizontal plane, and now we are building the wall, this square on vertical. So we have to add 3rd dimension. So this is, and this square would be 2-dimensional, but on vertical plane. So in total, this square, vertical square, it would have 2 dimensions, but different dimensions, because horizontal, on horizontal plane, we have dimension like left, right, or whatever you can name it, x, y, let's say. That would be z. So this so square at the bottom of the cube has dimensions x and y, these 2 dimensions. But the square on vertical plane would have only y and z, or x and z, only 2 of them. So not x, y, z. So the square cannot have at the same time 3 dimensions. Only 2 of them. So you can get rid of one of them, of horizontal, x or y, whatever. And it makes it 2-dimensional, but it doesn't make it as the whole surfaces of the cube 2-dimensional, because you have to involve or employ 3 dimensions to encompass cube, not 2 dimensions. Not x and y on horizontal plane will not suffice to encompass a cube. Simple.
It gets deeper though, right? He says, it's not a contradiction. No matter how often you assert it, a surface, any surface, can be two-dimensional. It has no depth. The surface of a ball, a cube, or a pyramid, they're all 2D. They're all areas, not volumes. A ball.
True. Ball, yes. So he's equivocating ball with like cube. No, and Euclid distinct.
Well, the ball, right? The ball, even within new modern mathematics, the ball is a solid, right? You can't pretend it's a sphere and go into the mathematical realm of a sphere. When you say ball, you are talking about the solid, the Euclidean sphere, right?
Yes.
Now, he's saying the surface of that can be 2D.
No.
Can only be two-dimensional, says the farmer's boy.
No, so he's just confusing one surface of the cube, one of 6, which is surface of one side, let's say, of the cube, with whole surface of the sphere, because sphere has, or ball has only one surface, and cube has 6. So he's equivocating, pars pro toto. This is false equivocation.
Yeah, I want everybody to get that, right? Take it in. I comprehend it, that he's saying the surface of a sphere can only be two-dimensional. That's a fallacy.
Yes, fallacy, complete false statement. I would say it cannot be. It is just opposite. It cannot be.
Gadget Inspector.
All right, Gadget.
Hello.
Yeah, I agree with you there, because let's take 2 points on a sphere, A and B. Okay, get a straight line. You can't get a straight line in a sphere. Okay, so how can you do it like a straight line in a sphere between A and B? You can't do it. No, come on, guys, help me out here. Hang on, I lost my train of thought.
Yeah, so it's good. It's good.
No, I'm trying to think of my train of thought here, because I was listening there tonight.
You have to redefine straight.
Yes.
Yeah, straight. A straight line is a straight line. The shortest distance between A and B. Okay, we all agree on that. And how can they define a straight line between A and B on the curve? We have to cut through the. If you have an A and a B on a curve, you have to cut through the ball, if you like.
Yes, but Darren said that. That's why I asked him about meaning of the words, because he said that this word has different meaning. So, in fact, when he was talking about straight line, he was talking about curved line, because we obviously know that there are no straight lines on the surface of the sphere, but he is naming it straight line. Just it. So this is just renaming.
Yeah.
It quite simply is, if you rename the circle as the straight line, then what are you going to call the diameter of that circle? If you've called the actual circle the straight line,
you have no name for that.
You can't, and then therefore pi would have to fail. You can't actually have a circle for the great circle to be if you're going to call it a straight line, because you've lost your ability.
And then you could only have one vertical.
Extra straight?
You could have a real straight line, couldn't you? You could have a straight line and the real straight line.
But Bev, what about the vertical? What about the vertical as well?
They're not allowed to have verticals. There is no vertical if they've only got 2D. They get rid of vertical. There's, like I say, the problems just keep adding on to themselves. That's why I say spherical geometry doesn't exist. There's no such thing as a spherical geometry. And that'll be explained every time that they cannot talk about the axioms or anything. No definitions. Nothing. So I said to a farmer's boy here, I said, my friend, you said you were obviously talking, you weren't talking about spheres being taught as having 2D surface, but you were. I said, did you get taught that at school, or was it the Flat Earth Society dogma that's allowed you to think like that, you know? Pretty much of a discussion. The 2D, 3D thing, I think, is fascinating. Obviously, not a lot of people do. They've had enough of it.
Complicated, isn't it?
I don't think it is complicated. I just think there's a bullshit argument that comes around it, and everybody knows that the moment you enter this conversation, people just walk away because they know that it's not allowed within the framework of all of the conversations you have with anyone. You're not allowed to have this discussion. This is ECV. So thanks for sticking with us, everyone. This is fascinating for me. Like I say, this is why I'm here. I was brought in by this bullshittery. Now, if you want to find the bullshittery, then this is where you have to look. This is where the proofs are. This is mathematics. The foundations of mathematics for everybody to discover for themselves. Nobody's going to tell you any of this. I mean, unless you're willing to trust Darren and Casey about, you know, Farmer's Boy. Casey says here, like as I said, she said, your understanding is wrong. The surface of something is 2D. The object itself is 3D, but the surface of it is 2D. That's taught to grade school kids, Bev. Perhaps you were absent, right? I say that's a contradiction, having something 3D with the surface being 2D. It's 3D to start off with. How can you backtrack a dimension? You can't remove a dimension of something that's already there existing in 3D. That's ridiculous. And Casey says, I'm saying that you are not qualified to decide what is an actual contradiction. Casey thinks that she can hand out to other people that they aren't qualified to find a contradiction within logical thought. Now, if that's not sophistry, and somebody trying to, I don't know, like what, literally, what is that?
That's someone who's butthurt, has no logic, and won't see the point, can't see the point.
So she's maybe this is not doxing, but this is like warning that because you are not qualified, you are not a professor of logic or whatever, then you are not qualified to decide what is contradiction. So it means that maybe in the future we would have that situation that some people will be not allowed to use their reason because it would be bad thing.
You're not allowed to use logic.
Yes, if it is inconvenient for a model or whatever, or ideology, whatever, because you are not qualified. And who would qualify you?
So Casey is saying you're not qualified. I say Casey is a flat earth society.
I'd say this at this point, right? What Casey's saying right there, it takes it beyond a flat Earth argument. What Casey's trying to do there is literally 1984. Casey thinks that she can administer who can and cannot have logical thought.
Ministry of truth.
Absolutely.
Absolutely.
Casey's
That
placing
this
herself
sort of
as
shit
Ministry
needs
of
fighting
Truth.
about, right? This literally is worth fighting about. This is a mathematics acclaimed mathematics teacher in Canada telling somebody else that they're not qualified to think logically.
Wow. That's crazy.
That's the argument now. That's how bad it's become for them.
Hey Bev, is Casey too has she got a YouTube channel or is she...
Yeah, I think so, yeah.
Yeah.
The main surveyor said he linked it to it. Okay. On the bottom of that video. The Euclid and parallel lines.
I would not done it.
So she said, I'm saying that you're not qualified to decide what is an actual contradiction. Literal 1984. But Casey's a nobody, right? Just a troll on Twitter from a few years ago that literally thinks that they can do this. And this isn't just her. This is literally everybody that has ever talked to me has told me that I don't know. Luckily enough, I'm me. But what about if I was anybody else?
Yeah, if you had a weaker mind. She's acting like a school teacher.
Mm.
Yeah, you can't do that.
Experts decide on curriculum, Bev, not you. I wasn't saying that. I just said there's a contradiction. And I said, and I'm taking you at your word that this 2D surface of a ball is within the curriculum in schools in Canada. Can you tell me which year it's introduced, please? So if anybody's out there, right, if you're in Canada, if you go to any schools or anything, if you've got kids at any schools within mathematics, can anybody check that where this is in the school curriculum, where people get taught that the surface of a sphere is 2D, whilst the sphere is 3D? I'd like to know. I really would. Because this is something I think needs to be sorted out. I wasn't aware that this sort of stuff was going on in schools. I say a ball is 3D and its surface is 3D. To say it's 2D is introducing a contradiction. I don't have a contradiction in my globe. Try thinking. And then Kenny comes in. Kenny's another one. It's a blue marble scientist. Darren came in to defend him, I think. Kenny says, how have you become so misguided? Surfaces are two-dimensional. They have no depth, thus cannot be three-dimensional. It's not a contradiction. It's your personal understanding. Kenny, again. And then go on, sorry.
I was just going to say that person believes that in his model that he lives on this thing that he calls 2D and that has no depth.
Everything he touches, everything, literally everything. He walks on, he steps on, he sleeps on, he showers in, all water, everything. 2D.
He does. So he does realize, I would think, that on this thing that he lives on, like the rest of us, that there are these people who dig down, sometimes very long way dig down, and there are some people that dive down into the liquid parts of the thing that he lives on. He does realize that, right?
Just
when he says there's
more,
no depth.
Just exposes more 2D, I think.
Oh, I see. So 2D becomes 3D somehow.
2D.
Interesting.
Yeah.
So if you are scuba diving, so inside the water, still you are on the surface of something. I don't know.
Does would any diver say that while they're 200 feet below the quote surface that they're on the surface?
Well,
They are
see, the
on
water would
surface.
be touching the surface of you, which is 2D.
Oh.
See? You become the surface at that point. I don't know how it works. If only we could ever have somebody to come in and explain it. But as we know, they can't. So we're left imagining it for them. But I don't like to imagine this stupid shit because it doesn't make any sense. So I did a tweet. I put a tweet out. It said, this farmer's boy thinks that the surface of a ball is 2D. Laughing face. What on earth could make him think that? And then it's a quote from Roger, farmer's boy, a farmer's boy. Says, it's not a contradiction no matter how often you assert it. A surface, any surface, can only be two-dimensional. It has no depth. The surface of a ball, a cube, pyramid. And then KC says, because they all stick together. It's all the same group of people always. Especially in my group, you know, like I know I do follow the same. Well, I don't follow them. They follow me. The same group of people follow me. And that's where we get into this. And Casey says, because all surfaces are 2D, hence why we talk about surface area and not surface volume. Globe Turd Society says, exactly. I'm pretty sure Bev is a Poe because you have to try really hard not to understand that, lol. I don't know who he is. I say the surface of a sphere does not move with all three dimensions, though. I'm not sure we both have the same understanding of a three-dimensional solid as described in the Elements Book 11. To which KC, the mathematics and geometry teacher, supposedly, in Canada, says the surface of a sphere is not a three-dimensional solid. In fact, if we're being totally pedantic, a sphere is the outer shell of a ball. The ball is the three-dimensional object, the same as a circle is the one-dimensional edge of a disc. I'll say that again. Casey, says, the ball is the 3D object, the same as a circle is the one-dimensional edge of a disc. Now, who does that sound like? That's Blue Marble Science, isn't it? A disc, a circle, is the one-dimensional edge of a disc.
Sounds like a lot of flat earthers I've heard.
Circle is not edge. Circumference is edge. And this is line, and curved line is not in one dimension. That's why the dimension is measurement in one direction, and curved line is not going in one direction. That's why curved line cannot be named as dimension. Only straight line can be named as dimension. So circle is not circumference is not one-dimensional edge because this is not dimension. Curved line is not dimension. As mathematical definition of dimension states, in one direction, it has to be straight line. If it is not straight line, it is not dimension.
Yeah, it must be. I'd imagine that's why there's no Dogmatic Globe people watching anymore. They can't even hate watch this because this would be embarrassing for you to have to answer questions about this. It's better you just pretend you've never heard it. So if anybody's listening, practice this out, right? Next time, this is Dogma. Dogma sent out to the Globe Fanatic fan club. Ask him. Try asking anybody about it. You won't be able to have the conversation about this. The only place you get this conversation is people in text chat trolls stating absolutely ridiculous shit, claiming that they're mathematicians talking something that a mathematician would never say.
So paper. So a straight line on the globe would have to be 3D. Is that it?
You wouldn't get a straight line on a globe.
No. Not 3D. Not 3D. Curved line is curved. It may be in 3 dimensions if like spiral line can be in 3 dimensions because you can curve in different directions. Not on the plane we have circles, so this is curvature in one constant. This is called constant curvature. But you can deviate this curvature in different directions. So this curvature can leave the plane and then you will go into 3rd dimension. No problem.
Yeah, so you have length, breadth, and width. That length, breadth, and width is 3D.
Yes, because if you are talking about dimensions, this width, breadth, and length is treated as directions, not as property of something, of an object, for example. So we are not talking about thickness. We are talking about directions. So, and directions are different because they are in 90-degree relationship between them. That's if they are called length, breadth, and width, or X, Y, Z, or whatever else, it doesn't matter. They have to be straight lines in a 90-degree. They have to be perpendicular to each other.
Absolutely. Yeah. So the minute it goes off the 90-degree, it would be in 3D.
Yes. It will be. It is entering different dimensions.
Yeah. Just wanted to make that clear.
Okay, I have to go to bed. Good
Okie
night.
dokie.
Thank you very much.
Good night. Okay. So here we go. Next one. This one I think sums it up into a nice, neat little package. I say the solid sphere is 3D and it exists in Euclidean space. Casey says its surface is 2-dimensional and is non-Euclidean. Does anybody want to have a stab at that? Its surface is 2-dimensional and is non-Euclidean. Anyone? You want me to do it for you? 2 dimensions is Euclidean. So how can the surface of a sphere that is 3D, that is also Euclidean, not be Euclidean? Its surface is 2-dimensional and is non-Euclidean. The surface of a Euclidean solid, in reality, is non-Euclidean.
I bet 2D is Euclidean, right?
Pardon?
2D is Euclidean.
Yeah, two-dimension is defined as a plane in Euclidean geometry, yes.
Absolutely.
But Casey thinks the surface of a sphere is 2D, and it's not Euclidean. Basically, she's just fucking made shit up.
Cool.
This is the dogma. This is the model for the dogma globe model.
No, because 2D is Euclidean. Has to be. Shit.
Mm-hmm. Yeah, it's straight lines.
Yeah.
Yeah.
Has to be.
Okay,
carry on. Sorry.
They can't have they can't have the straight line that they have as circles be in a dimension, can they? Okay.
No, they can't have that. No, if not, you go into 3D. Has to be.
Mm-hmm.
Go on, carry on.
Casey says there's no paradox, Bev. There are multiple uses of the same word. Horizontal and vertical are defined on a plane. There is a similar but different definition of them on a globe. It's word usage, not a paradox. I'll state that again. This is Casey, the claim to be mathematics teacher in Canada, that claims that she works in school and teaches this to school. So please let us know whether this is a curriculum within Canadian schools. I'll state this one again because this is fantastic. Casey says, there is no paradox, Bev. There are multiple uses of the same word. The words being horizontal and vertical. They're defined on a plane. There is a similar but different definition for them on a globe. It's word usage, not a paradox. It says, I can ask somebody to draw a horizontal and a vertical line on a piece of paper, and they can do that in 2 dimensions. But it won't match the understanding of vertical we have in something like construction.
I bet. Do you ever learn that in school? So you can have verticals and horizontals, and then you can have verticals and horizontals on a globe. Do you ever learn that in school?
There's only vertical and horizontal in reality. There's only one.
Yeah. But for them, you can have verticals and horizontals on a globe. Did you ever learn that in school?
No. Not at all. I don't know whether anybody would have done.
No.
Anyway, is there anybody out there that has learned the different definitions of horizontal and vertical as pertaining to on a plane?
On a plane and then on a globe.
Well, on the plane, let's say the horizontal and vertical they're straight lines, right? Or planes. They're either a plane or a straight line. Now I'm pretty sure that's the understanding that I have of horizontal and vertical. So does anybody have any sort of different, has anybody been taught this other usage of the horizontal and the vertical? I know not many people are willing to talk tonight. It gets a bit tricky.
Bendy horizontals.
I've heard of bendizontal, but that's not a different definition of horizontal, right? That's a completely different word. It's a bendizontal.
Yeah,
conceptual.
If you have a bendizontal bend, you have to have the bendy vertical as well, or no, you wouldn't call it the bendy vertical. What would you call the vertical?
Well,
how would you call the vertical if you have a bendizontal? What would you call that one?
I wouldn't call I don't. There's no such thing. I only have vertical and horizontal. But Casey says, but it won't match the understanding of vertical we have in something like construction. Now, Casey isn't maybe not aware, but when I got my land surveying certificate that I have up on the wall, I was sitting a BTEC in building construction. And so strangely enough, I've done surveying and building construction, and I understand that horizontal and vertical are on a plane or a straight line, right? A straight line on a plane. So I understand all of that, and I've done building construction. I've actually done drawings. I've done drafting. I've done surveying, like I said. I've done bricklaying. I've done joinery. I've done plumbing. I've done quantity surveying, concrete. I've done all of that sort of stuff. And Casey here says it won't match the understanding of vertical. Well, vertical's a straight line. I don't know what's the difference. Literally, up and down, vertical. Everybody understands what vertical is. There's no different definition of vertical, particularly within construction. Vertical is of an utmost importance in construction, as is horizontal.
I built many a wall, Bev. And when you start off a wall, say a little garden wall, you start off by the vertical.
You start off with your horizontal base first, surely.
I know. I go
you
with
don't
the
build
vertical.
it with 45.
Oh, I always call me vertical. First brick. Oh yeah, I do the foundation first, of course, with horizontal. Yeah, and then you go with the vertical. You know, when you're starting to lay your bricks, you have to have the vertical first. You have to get to 90. Yeah.
Yeah, you have to start off with the horizontal, and then you have to make sure that you're building the wall vertically from that horizontal base. I mean, KC here, the Canadian school teacher, the mathematics school teacher, doesn't seem to be having any sort of idea or understanding of construction, the very thing that she's talking about. This is about as bad as it gets, really. Is anybody doubting that she might not actually be a mathematics school teacher? Because this doesn't sound like school teacher behaviour. It doesn't sound like it should be allowed as school teachers going out there telling people that they're teaching their kids. Oh, wait a minute. School teachers are fucked anyway, aren't they? How much weight does a school teacher have nowadays?
It sounds like farmers by soccer camp. Probably. I don't know. Let's see.
There's no paradox. And this is where I reply to Casey. In construction, as shown in all architectural drawings and elevation profiles, vertical and horizontal are both straight and perpendicular always. The mathematical properties are replicated in reality within the perpendicular axis of Euclidean geometry. Hence, #realizing Euclid. We have already got a test set up for this. I mean, I'm not just talking bullshit. I'm literally telling you, we've got a proof. All of this bullshit that Casey's talking about can be countered with actual proofs in reality, mathematical proofs. It's not going to be very popular, I'm telling you.
So we know that, Bev. We
Pardon?
know that.
Yeah.
We know that.
I know, but it's just not like we are only a small group. Probably best it stays that way because there's a lot of shit comes raining down at you the moment you start talking about this, especially within this arena. And this is Don't know who else is here. So I hope there's somebody else listening to this, because this is the point that I wanted to go over. Make this clear to everybody. Casey says, yeah, I just found it. Just wanting to make sure that we're on the same page here. Not sure what he thinks the third dimension is. And definition 2 within book 3. This is on the internet. It states, I don't know whether I can see that, whether I can blow it up enough. Let me just get whether I can. Because this is pretty important. Now, I don't know whether anybody else has been following us and through the journey of how we came here. When we first came in here to do this, the Wikipedia water level thing was different than it is nowadays. It's been changed a few times since we came to this arena and started talking about these arguments. But what we're going to show you now is a change that we've found that these people have actually showed us. You see that? This is Euclid's Elements, Book 11, Solid Geometry. And the definition 2 states, the first definition, definition 1 states, a solid is that which has length, breadth, and thickness, depth. 3 dimensions. Length, 1. Breadth, 2. Depth, height, 3. 3 dimensions. Definition 2 states, a face of a solid is a surface. Have we got anybody that wants to take that on? A face of a solid is a surface. Definition 2.
It would be a face of a solid is a surface. Could be.
Do you know what a face is?
Yeah, something towards you. Yeah.
Within geometry.
A face of a solid is a surface. Well, it's solid. It would have to be a surface, wouldn't it?
Sure.
A solid is that which has length, breadth, and I can say length. A solid is that which has a length, breadth, and distance. No,
thickness, breadth, or it doesn't really matter. It's just the third, whatever you call it, width, height, depth, like whatever you want to call the third dimension. It's just to show there are 3, a solid.
So, can we see the third?
Depth. Length, breadth, and depth, that one calls it. My Euclid element says length, breadth, and thickness.
Length, breadth, and width. That's normally what we call it, no?
Okay, so this one here is my book, Euclid, and definition 2, like here it says, definition 1, a solid is that which has length, breadth, and thickness. My book. Change that for depth if you want. And then number 2, definition number 2. That which bounds a solid is a superficies. Sounds different, right? Sounds different to a face of a solid is a surface. Can you hear the difference in it? Remember, these are definitions. A face of a solid is a surface, or that which bounds a solid is a superficies.
Rebecca, what does a superficies mean?
It's the superficies.
Super macro.
Yeah, it's that which bounds a solid is a superficies. The superficies is defined as that which bounds a solid. It's a definition. So what bounds a solid?
Surface.
A superficies.
Yeah, but it would be a surface then, no?
It could be. Definitely within solid geometry. Yeah, you could definitely call that a surface.
Yeah.
I've got a thing here now. Let me just go to. Can you guys? Oh, you can see that, can't you? I just shut that off.
Jeff, look at number 4.
Right, can you guys see this here now on my screen? It's just Wikipedia. I mean, I don't know how much we're going to take from it, but it is Wikipedia. And it says, face, geometry, from Wikipedia. In solid geometry, a face is a flat surface, a planar region that forms part of the boundary of a solid object. A three-dimensional solid bounded exclusively by faces is a polyhedron. It is more technical treatments of the geometry of a polyhedron at higher dimension, the polytropes term, blah, 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 blah. Polygonal face. In elementary geometry, a face is a polygon. On the boundary of a polyhedron, other names for polygon face include polyhedron side and Euclidean plane. So are you okay with that? A face is a flat surface, a planar region, also called a Euclidean plane.
So a surface.
Well,
would you call that a surface?
It says here in Euclid's Elements, the one that Casey's given us, that a face of a solid is a surface. It's going to come in quite important, right? A face of a solid is a surface, and a face in geometry is a flat planar region, also called a Euclidean plane. Carry on. There's not many more to go here.
Before you carry on, I must stress, hey guys, whoever's not subscribed to Try Thinking Discord, come in here because we have this every day. It doesn't have to be just at night, 8 o'clock at night UK time. You can have this conversation any time of the day. So come and join the Try Thinking Discord.
Thank you.
I'll put the link in the chat.
When I said in construction as shown in all architectural drawings and elevation, Kenny came along to defend and says, you do realise that she was referring to geometric constructions not building constructions, right? Kenny, I don't know. Kenny was trying to J-Ro put here just to go along. A sphere has 0 edges, 0 faces, and 0 vertices. Just for you to keep up with. It's not a contradiction no matter how often you assert it. A surface, any surface, can only be 2-dimensional. It has no depth. Surface of a ball, cube, or a pyramid. And then I think this is Farmer's Boy's friend. He says a curve is a 1-dimensional object. Objectifying 1D. Though if it isn't a line, it will exist in a higher dimensional space, 2D, 3D, etc. The objectified 1D. He says a surface is a 2-dimensional object. Though if it isn't a plane, it will exist in a higher dimensional space. I said, I'm sorry. I know 1D and 2D are concepts, and as such are not objects or things. My mathematics is foundational. I'm not into this modern day mathematics.
That's crazy.
This guy says, sir, there is nothing modern about my statement. That's how lines and surfaces have been talked about for ages as objects, 1D objects and 2D objects. He's talking bullshit. Unless he's just been talking with a load of dogmatic globe believers. He says, if you can't or won't understand that, you have 0 credibility. This is where the intentions of it are. You have 0 credibility designing experiments that rely on knowledge of geometry and mathematics. They're talking about the realizing Euclid tests, and that we don't have any credibility in designing tests. It's so bad.
They're trying to redesign reality.
Uh-huh.
Yeah.
For the globe. For the globe. Whereas I'd say just get on the real globe. This dogmatic globe just makes you look fucking ridiculous.
Yeah, we don't care. We're on the real globe here.
So this one here. I say, I agree the Earth isn't flat. And then put a link to the website, Tis Globe site. And Undeclared Vegan says, and 10 years or more yet, you still don't know what level means. Again, we are the home of levelology. We're building a philosophy around it. If there's anybody that knows more about level than we do, please let us know.
Please stand up.
Yeah. Send us a link or something. Come and have a conversation. Like we want to improve this knowledge of it.
How many years did we talk in here? Level is horizontal and all this shit for that past 4 years. Come on, bring it on.
Yeah. He says, so for fun. This is the guy. So for fun, because I don't understand it. He says, as a Brit, you yellow lines on a corner where you shouldn't park. Those yellow lines are painted level with the curb corner. Hey presto, level and curved, not rocket science, he says. They're not bright, are they? Level with the curb on the, like, I don't know. But
well, yellow line, it could be level. You know what I mean?
what?
You know, do you see that yellow?
It's on the road. It's on a curb. It's a yellow line at the side of a road.
Yeah, but the road could be level. So the line would be level. Could be level.
And curved.
No, if you look at it, you know, because we're looking at it like that. But if you bring it around to level, eye level, as you want.
Eye level? Definitely not.
Yeah.
You wouldn't have your eye level on the floor like that. No, that's ridiculous.
No, but it could be level. The paint. The paint could be level.
You'd have to level it though, wouldn't you, to make sure it was level?
Yeah, absolutely.
But what you'd look like a muppet, wouldn't you? What are you doing? I'm just leveling this bit of the road here to make sure, because some dude said that we could put a level if it was level to the curb. Literally, that's what he says. Look, you don't try and justify it.
No, I'm just saying that you could have a level piece of a parking space, right? It could be level, and then you could paint a yellow line on it. No matter what you did, you could squiggle on it, but the paint would be level. You know what I mean?
Well,
that's what I'm saying.
I don't know. I'd say it's a ridiculous statement, because what he actually says, you're trying to justify it for him, right? What he says is those yellow lines are painted level with the curb corner.
No.
They're not. They're just painted on the road.
Yeah.
They're not painted level with anything.
If the road was level, yeah. If the road, yeah, but then...
But you're assuming a if for him within his statement that isn't mentioned.
I have to stop talking.
Yeah, you don't need to do that, right? Literally, you're helping him. Okay.
It's pretty terrible, that. Yeah. Go on. Carry on.
I say the surface of a sphere is not defined in the new definition you've just shown. The one that earlier that stated the surface is a face. Right? So the surface of a sphere is not defined within the definition of solid geometry that she gave. I'll go back and show it here. This one that she showed, him and Kenny as well. A face of a solid is a surface. According to that, there is no definition for a surface of a sphere. It's literally not defined. Do you get that?
Yeah. Face of a face.
Where did I put that? What's that? Oh, yeah. Oh, it's the last one. Yeah. The surface of a sphere is not defined in the new definition you've just shown. That's the definition that's been changed. It's not the same as my Euclidean definition. And when they've redefined it, there is no definition of the sphere. Because the sphere doesn't have a face. Although KC says that is a definition of a face. So KC thinks that the redefinition of a superficies is of a face. Now, the surface was defined back there. So a face is a planar figure. So how can you have that on the surface of a sphere? There is no surface of a sphere defined within this definition that these people have given us. Now, I don't know where this thing is. Who's given us these definitions? But they've literally changed the definition of Euclidean geometry around the surface of a solid.
Oh.
I've literally taken away the surface of a sphere from Euclidean geometry in book 11. This definitely needs looking into, people. There's only 20 odd people listening to us.
Yeah.
This is massive. Literally, I'm saying this is huge. They've took out the surface of the sphere from Euclidean geometry. The sphere exists, but there's no definition of the surface of it within Euclidean geometry. They've literally redefined a surface to be exactly the same as the original surface of two-dimensional geometry. They've made the surface 2D.
A face. Right.
Yeah, that's bad. And I'm not too sure how anybody, if anybody wants to come in and talk about it, if there are any mathematicians, I know this is going to be a hard fucking conversation for anybody to have, but these are the conversations that we have to have, and I'm not too sure who's going to have them. This is the fundamental understandings of mathematics that it's at stake here.
The definition of a face is not a surface. That's what you said.
No, she said that is the definition of a face, not a definition of a surface. Let's get it back again. A face is a solid. Face of a solid is a surface. That's a definition of a face, apparently.
Solid. Okay. The face of the moon. Okay. We go by that.
Yeah, so now what's a face then? Gadget.
It's a solid.
No. What's a face in geometry?
For me, a face is a planar plane. A face. Something. If I'm looking at a solid object, a face of a solid is a surface. Yeah.
Yeah, and a face would be a square.
A square.
Or a circle.
Yeah, it could be a circle.
Well, that's 2D, isn't it?
Yeah, in 2 dimension. Yeah. Absolutely.
So
yeah. Not curved.
What's the surface of a sphere?
Like a little, probably little tiny tangent, probably. I don't know.
How many surfaces does a sphere have?
Loads, but when we're looking at a face, it only has one. It wouldn't even have one.
It can't have one.
No.
A face is planar.
A face is planar.
Yeah.
A circle couldn't have one.
A sphere. A circle is a two-dimensional.
So, Bev, what do we say the face of the moon?
That's literally, if you're talking geometrically, you're saying flat planar, right? Like, you know, I'd have a word with Bob, the former doctor.
Yeah.
The science guy, because he's researching the flat moon. And I'd say that's because it has a face. Akumu Virus says, a sphere has one face. Akumu Virus, have you redefined face? Because a sphere does not have any faces. That's ridiculous to say a sphere has one face.
A face solid is a surface.
Yeah.
Yeah.
According to
There you
that
go.
definition, Akumu virus thinks he can define a sphere as having one face. Just shows his geometric ignorance. Akumu virus, if you didn't know, it's literally took it.
Yeah, just look it up, Bev.
Yeah.
Look it up, Bev. Yeah.
A face is
You
a
guys-
planar. I will. I've just looked it up before. Akumu.
Yeah, look it up.
I will. In fact, I'll get it as a screenshot for you, Akumu, just in case you didn't see it. And I'll highlight some. Oh, come on.
Shows the face of the basketball.
Oh, what's going on?
A pig is one face, Jeff. Yeah, absolutely.
Oh, I can't do that for you. I don't know what's going on with my thing at the minute. But look it up for yourself. Don't tell me to Google it, Akumu. You check out what a face is.
Yeah, Kuma's a good boy. He knows how to do that.
Hopefully. So I don't know. I'll have a look at what's on here. Going. I wanted to go to another video, and go over that.
You're going in there tonight?
No, I'm not gonna. I can't go over another video tonight. So I've been going 4 hours already. I'd like to thank everybody for watching and listening. There isn't that many people. We expected this sort of thing to occur. It may sound like we're going over the same things. Does it say it curves, Akumu virus? Can you see any curvature of a face? Or does it say it's a polygonal surface? But thanks for being here. Thanks for watching. And, well, it depends whether you like this sort of stuff. This is literally me finishing off. I've taken everybody back through what I've been doing so I can just sort of say goodbye to it all. Ridiculous stuff. I'm just showing everybody how ridiculous this is. I've been away from it for quite a while, but there are people that have rejoined us that haven't been through this. So I'm hoping you will get an idea of what's going on within the mathematical understanding. My mathematical understanding has increased tenfold from what I knew before I started here, especially within the metaphysics area. Logic, understanding logic, and understanding of the basic concepts of geometry, for first principles sort of stuff.
Face is a flat or curved surface on a 3D shape.
Well, it's not in the bit that I did. I don't know where you're looking. You must have found somewhere. Face is a flat or curved surface. You've added that in there. I'm not too sure about that. Because of a sphere, you'd have to have a face that's on the back of itself as well.
Yeah,
That just doesn't make any sense. Not logically or anything, Akumu virus. But I know, we understand you have contradictions that you have to get around. We know that. Like, dude, maybe it depends on geometry. You can't change geometry. There is only one geometry. Euclidean geometry. For reality. That's what we're talking about. We're not talking about conceptual things. We are actually talking about geometry. And yes, you're right, Akumu virus. It's not science. It's already settled It is completely understood. Euclidean geometry is a perfect axiomatic system, faultless.
Euclidean geometry is reality. There you go. Listen, Beb, I'm off to bed. Good night, everybody.
Okay. Thank you very much, Gadget. See you later.
And have a great night. Cheers.
Yeah, Kumu Virus, thanks for being here. It's good for you to be here. Model Affliction Monday. Hopefully you've kept everybody happy in the chat there, with your ridiculous statements. One face of a fucking sphere. But that's a good one. That's a good one for us to go over now, since that redefinition has been made within Euclidean geometry. I find that amazing. It can't have been because of us talking about this, surely. Why would they want to define that, change it? There must be some reason why they've changed the definition of Euclidean geometry to not include the surface of a sphere. Maybe it's because they want the surface of a sphere to be non-Euclidean. Who knows? And we'll talk about these sort of things in the days, the weeks to come, I think. These foundational concepts are something that does definitely need to be talked over, and we will talk over them to prove why they sound ridiculous. But they are just conversations. Anybody's free to come in, Akumu Virus, if you want to come in and have a chat about whatever concepts you imagine them to be. But I would imagine there will be a good argument presented against it. Not shouting arguments, proper arguments to counter as to why they will. Rational, reasonable answers, questions, arguments. We can do it all. Come for a conversation. Tomorrow we will be doing another short one, and then we will be going into the philosophy course at Hillsdale College. So come and join us for the beginning bit, but then more importantly, come into the Discord. Come and get involved in the philosophy course that we're doing. It's getting good, and it was really good last week. I enjoyed it immensely. Okay, thank you very much. If you want to discuss any of this sort of stuff, you know where to come. Thanks for joining us. And Buster's going to sing us out. Be at peace with your monad, whatever shape it may be.
All right, here we go. Okay. Is it a hump or a drop? What do you say? You got to twist your words in every which way, because the motto will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line or does it curve? Some people unclamp it, but that is absurd. We all know that the model will always dictate what you do. Everybody knows that you are model afflicted blue. Model affliction. It's your addiction. That model affliction. It brings you so much pain. It's your ball and chain. Conflating curvature with elevation change has got your local distance just out of range. That old biggie is gonna dictate everything that you do. And everybody knows that you got the model affliction blues. It's your decision defending the model position. You just don't know the geometric proposition. That old ball, it'll always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction, it's your addiction. Model affliction. It brings you so much pain. It's your ball and chain.
World famous Buster.